Hello. Welcome. Going to write some OCaml today. All right. So yesterday, set the project up, and we wrote the lexer, which should be good enough for now. Need some small tweaks. Barak. Hello. I will pray for non-async parser. It will be async. I mean, in OCaml, the asyncness though is implicit, right? How do you even write async OCaml? How do you even write async OCaml? You can, but the code will not look like async. Async in OCaml is going to be a lot simpler than in cast, you know, but it's going to also like so async works through. I mean, I might be wrong. Let's see actually. Let's actually see how to write async in OCaml. There are actually two things: LWT lightweight threads or async. Like, look at this: fetch data, right? This says LWT unit sleep 1, and then return data fetched. This looks like Haskell to me, basically. This over here is and then, which is the bind operator of a monad, basically. I think this is weird. And then since this is basically a monad, a promise monad, right? And then you need to run the promise. This is basically the alternative of block on, I guess, in Rust. This is monadic bind, yeah. You will live in pain now, yeah. I will not write code like this. I will, like, because monads in OCaml, they're not as good as in Haskell. So instead, how do they do it here in the Jane Street? Oh, this is still the monadic stuff. Okay, I'm wondering like why. So right now OCaml use Rust. Yeah, but so I think there is a third alternative here, which is through the effect system. So hold on. What about the effects? They can do async too, right? Oh yes, effects. The new shiny toy in OCaml 5. Effects can absolutely do async cleanly, modularly, and without chaining any 800 binds, like some cursed Lisp. All right. So yeah, basically, oh yeah, there is effect-based async IO runtime. Like, look at this. This is like a normal function. You just say sleep, and then you print like a normal function. So the problem is that the async is no longer in the type signature, unlike with the monads or with Rust, but it is still async. You just stress codes that suspends and resumes. You know, if you try the language like, I guess, what is this similar to? If you have tried a language which allows you to suspend and resume, like this feature is called fibers sometimes. I remember in D language has fibers, right? Hello, Nigel. So you write code as if it was a normal sync code, but then your normal sync code can basically yield. Yield means that like pause current execution, right? This means pause the execution of the current like thread. It's like cooperative multi-threading, where you explicitly say that you want to pause here, you know, and give control to another thread, kind of. thing, you know? So yeah. Anyway, let's do. Also, I have improved the thing a little bit since yesterday. Most importantly, Nigel, I found a way to make the find the replace work, the rename work across the whole project. That's the biggest thing. There is a way to do this in OCaml. It's a new thing, though, I guess. So the LSP support, in order to support your LSP, you need to not just do build, but you need to do build OCaml index. OCaml index is like the new thing which builds the index of your entire workspace, of your entire Dune project, which allows you to rename across the files. And also, like, not only rename across the files, you can also, like, previously I couldn't even, for example, find all of the is it fast though? Yeah, it is fast. I mean, at least for now. My project is tiny right now, maybe, I guess. Like, you can also find all the references of a thing across files, not in the current file only. So, like, this makes it actually work, which is good. I changed this. I changed the layout of the project here a little bit. I moved the Lexer into its own, like, crate. I found this thing, which can generate me the image of all of my dependencies. So here's the goal, right? We want to have cast, we want to have compiler, interpreter, and all of this stuff. So far, we only have this small part, which is the Lexer, right? And this is what my current dependency graph looks like. UML programming, let's go. Do you have a way to make U32 more than 10? Or colon U32? What are you saying, Brian? U32 more than 10 question mark. Like, or... Wait, hold on. Is this like two thing? Is this two questions or one question? Integer with ranges. A U32 more than 10. You mean like refinement types? That's what you're asking? And what are you asking about? Like, are you asking about OCaml or cast? As far as I'm aware, OCaml doesn't have refinement types. Cast doesn't have refinement types yet. I was going to look into that at some point, but it's not there. It never was implemented. I never implemented dependent types either. But I wanted to. There is a lot of features that I didn't implement. Well, OCaml index needs MLI file? No, it doesn't. No, you just edit, and that's it. Everything else just works already. I mean, it's a newer feature because OCaml index was introduced like in January this year, as far as I understand. OCaml index. I was just looking for the stuff, and this literally just there's Dune. This alias, yeah. This is the targets necessary for development tools to provide project-wise queries, such as get references of these values. Right? I don't know like how you figure out when was this introduced, but I'm pretty sure it's like this year. I want to support refinements though, Brian. Yes, refinements are good. Although, and independent types. Dependent types, are you gonna JIT or will you just compile? What do you mean to do dependent types? Are you gonna do JIT or will you just do compile time ahead of time? In order to do dependent types, as far as I understand, you need to potentially run programs at compile time, which means you cannot do it ahead of time anyway. But JITting is not necessary. You can do it with a normal interpreter. But if you do JIT, then your like dependent types is going to be faster, obviously, right? Because like dependent types is, once again, you need to be able to run code at compile time, basically. And if you JIT it, it's just going to be faster, but it's not necessary to be fast, right? Compile time execution was already implemented before. And I'm pretty sure that if I really wanted to, I could get the dependent types. I just didn't really try. Your getting could not find the CMI file for interface for your executables. I don't remember. Why JIT faster? You mean for the types that are not compile time? Well, I mean, you need to be able to interpret. You need to be able to run code at compile time. You need to have an interpreter at compile time. If that interpreter needs to be fast, to make something fast, you need to compile it to native code. And because it's an interpreter, it needs to have a JIT to have to run at like native speed. Because you cannot ahead of time compile when you don't have everything yet. You know, it's like you need to do just in time, basically. That's my understanding, at least. Maybe I don't know. Have you made a language with dependent types? All right, we have the Lexer. I'm going to start with the parser today, right? Dependent types and types in general are not going to come in this rewrite soon. Why not compile if you do just do interpreter to if you just do interpreter to then make a JIT? I don't understand the question. Why not compile if you just do interpreter to then make a JIT? What's the question? I don't understand what's the question. Why not compile? Like you have to have interpreter because you need to run code at compile time. So yes, there is both compiler and interpreter. Compiler is the interpreter. This is the idea here. We have compiler. Compiler is going to invoke the interpreter. So compiler is going to compile the code using the interpreter, convert it into the intermediate representation, which is what the interpreter is going to then interpret. We have both compiler and the interpreter, and then and then interpreter when executing the intermediate representation, it can do the JITting to be fast, but that's like an optional thing. Being fast is optional. All right, at least for now, because it's more work. All right, parser, parser, Dune. Parser. Does parser depend on the Lexer though? I feel like so technically Lexer, what it gives me, gives me just like a list of spend tokens, kind of. We can make it depend on the Lexer. Fine. That's fine. Parser, ML. Most time executed code isn't that heavy based on what I used it for. Yeah, it depends on what you use it for. But like as far as I understand, for example, languages like Lean and like in general, like with dependent types, right? Because you have not used dependent types. You basically write proofs for the fact that your program is correct. And in order to prove the proofs, you need to like that's the code that's being executed at compile time, right? That code is pretty heavy, as far as I understand. That's why these languages are slow. Yeah. The other code that runs at compile time is procedural macros in Rust, right? So if you are a heavy macro user, you might want to JIT those. How do you know if you have an interpreter that... How do you know if you have an interpreter that then gives you code to a compiler instead of a multi-stage compile, where you compile the things, you can compute at compile time, where before the... What do you mean, how do I know if I have an interpreter that gives code to compiler? What? I don't understand your question. How do you know if you want to compute? What? The thing you want to compute at compile time before into the transition with the results. Huh? I'm having trouble understanding the words that you say. How do I know? Well, I know when I implement it, I know what I have, right? And I have already implemented the thing before. We're in the rewrite. Okay, what's the interface of the parser? We're going to have parser, right? Parser is going to be... We're going to have the function initialize, which is going to have the source. The source, and it gives me the AST, I guess. So we have the AST. How is the new parser going to avoid stack overflows? Why can the interpreter do that the compiler can't? Because interpreter is interpreting and compiler compiles. They are doing different things. What do you mean, why? Why are they doing different things? Because that's what an interpreter is, and that's what the compiler is. We're not going to have stack overflows because it's OCaml, right? OCaml doesn't have stack overflows, right? Have you ever had a stack overflow in OCaml? I don't remember having that problem. Well, mostly a lot of the things in OCaml are stored on the heap anyway because of like garbage collection and shit. It's just like all of my types were very heavy in Rust. Like, letrec foo is foo. Yeah, but like, how deep do you need to actually go there? Actually, like, if you say letrec foo is foo, isn't that... That actually is not going to stack overflow, right? Because that's the tail recursion. And tail recursion is basically a loop. So it's going to run infinitely, but it's not going. June. It's not going to stack overflow, I'm pretty sure. Let's try. Fine. Yeah, so that the stand, let's see. Let rec foo is foo. Boom. Right? Like this. Hello? There's a syntax problem here. Hold on. Line 3, characters 32. 34. In doesn't... What? What's the problem with syntax here? Oh, it's because like something like this. I need a double semicolon. I don't understand this exactly. What I need that sometimes. Okay, yeah, see, it's not stack overflowing. It's just an infinite loop because of tail recursion. If you want this to be not tail recursion, then we can do like foo and foo, I guess, maybe. How about this? We'll do foo twice. Is this going to Stack Overflow? This one does Stack Overflow. Yeah. But like my question, but how quickly does it Stack Overflow? Let's have depth here. Depth +1. We start with 0, and then I print f is send depth /n. Like, this is pretty deep, I would say, and it's totally fine. Right? Well, I mean, this is a very simple function, obviously, right? We only have basically like a single integer. I don't think I will going to have this Stack Overflow issue like I had in Rust. Okay, that's not initializing. Initializing should give me the parser itself. Yes. And then parse is a function that takes the parser actually no, initialization should not take the source code. It should have the like, this is just making a new parser, kind of. Right? Parse is parser. Parse is if I have the source and I have the parser, then I can get the AST, right? When I had the empty source file in Rust version, I was actually returning option. Should this return an option because I didn't have the variant of the empty AST. What if this time I actually try to do this? Just have a variant which represents the emptiness. No, not parser. And actually, you know what? Just like this graph goes, the parser is generating the AST. So we are going to make the AST in its own project. AST. Parser is what generates the AST. This is the definition of the AST. So this one then depends on the AST, because it is going to generate it. Or is there an arrow from compiler to interpreter? An arrow represents a dependency. Compiler depends on the interpreter, because compiler needs to invoke the interpreter to execute code at compile time. Normally, in most of the programming languages, that's not the case. But for me, it is. Right, type AST. So the parser is extensible. What does this mean? It means that we don't have, the AST is going to be very, very simple. The AST is very simple. It's either it's basically, either It's either like a complex like node, which means that it's a node containing other nodes, or it's a simple one, which means that it's a node that doesn't have children. The node that doesn't have children is like an identifier, right? Which just contains the token underneath, basically. So it's just a simple token, or a complex one. Okay. Here's the problem, by the way. Like, I am depending on the Lexer dot token, I guess. Here. I don't want to open the entirety of the Lexer though. Yeah. Yeah, I guess that's fine. We just no, let's do this. Type token is Lexer token. That's how we import one thing. It would be nice if in OCaml I could just say like use a Lexer token instead of saying this name twice. Because this also leads to, if I rename this, that it will also only rename this thing, right? And if I rename that it will rename the thing over there, which is completely different behavior. I want to be able to rename all of them at the same time. Potentially in the future. Okay, so we have a simple token. Or I have a complex token. A complex AST. Which is having children. Let's actually have this simple and complex like this. So simple has the token, and complex has the name. Let's just do it simple for now. We just have name, and we have children, which is AST list. So this is recursive, which means that I need to do the end here. Not here, right? Instead of this type, we need to do an end, like that. Because this is recursive. I feel like, let's do all of these three together. So basically what this is I'm going to convert the source code into the alternative of a Lisp. Do you generate LLVM AR? No, not LLVM. Not yet, at least. Maybe eventually, although probably not very soon, at least. Maybe in the far future. Yeah, we convert, like, the difference between this and a Lisp basically is that we have like, you know, we have like if, you know, and then if has children, so children is you know, then condition, else condition, you know. And technically children are not a list, you know. Let's actually do this immediately to be different. So children are going to be named, right? So then is equal to like some concrete like other inner definition, and else is equal to some other thing. So we have like not a Lisp, but not lists, but tables, kind of. You transpile to C or something. No, I don't, like, we have interpreter. But in the previous implementation, we had the transpiler to JavaScript, not to C. The when I'm going to do the native one, it's going to be like, I don't know, maybe transpile to C, maybe generate assembly myself, maybe use LLVM or crane lift, most likely. Although I don't know if you can use crane lift from crane lift. If I do it in OCaml, crane lift OCaml, does that work? I don't know. If I was using Rust, it would be for sure. Hello, Brainoid. How does it turn into machine code? It was never turned into machine code. Well, I mean, it will. When, like, it's planned, but it's not there. Right? LLVM is not the only option to be turned into machine code. There is a lot of options. Okay, so this is AST. I was calling this that thing a tuple, but this is basically a struct of ASTs. So I was calling them tuples. I want to rename this. That's also like actually yeah. Open util. I'm going to make this in the utility module. Module tuple. Let's see. What should be the name of it? But basically, the tuple, it has that can have both named and unnamed things. I guess record. We can call them records. Fine. They call them tables in a Lisp, in the Lua. You already did my website, but there's not a lot of info. Yeah, there is not a lot of info. We could make more. But I mean, the language is not ready, right? That's the biggest information that you are supposed to get from the thing. It's the first thing that's written there, right? And I'm rewriting it from scratch, so there is going to be a lot of progress for a while. What if we mail you the code and you turn it into machine code manually and send it back? I don't like calling it a record though. No, let's come up with a different name. So it's basically yeah, OCaml calls them records. Right? Labeled tuples. Wait, hold on. So over here they call them labeled tuples actually. So labeled tuple and a record is different. Labeled tuple extends you to allow labeled tuple elements. It's conceptually dual to labeled function arguments, allowing you to give a name. So is this like not a record? It's a labeled tuple instead. So maybe I can keep it being called tuple then, if even OCaml does that. Or at least the OCaml. Maybe tuple is not that bad of a name then. Do I have design notes or do I just write code? Mostly just write code. This is the biggest design node that I have. This is the only design node, alright? Lua table is the only other place I've seen that kind of structure. Yeah, I think Lua table is the only one. But I don't like calling it a table. I think table is a bad name. Let's call it tuple. Okay, so tuple is a tuple of A's, right? And this is basically there's going to be a record which has fields, which is hash table from string into. Do I need the parenthesis here because it's two parameters, right? And like this, string into the value like that. Is that not correct? Is it just string A? No, it's not. What's the format issue? Line 50 to 6 type. Oh, I need to do struct, of course. There we go. So this is but this is only named fields. So we have the combination. We have the abomination, the combination. We have both unnamed and named fields. So unnamed is just a list, and named is a hash table from the name. It's like calling it a chair. Yes, that's why we don't call it a table. All right, so that's what a tuple is basically. So AST. Type. A tuple is a tuple T. This. Kevender, hello. You cannot get on lists, by the way. Just letting you know. Use array for that. Oh, I need to do okay. Array. Sure. What does this exclamation mark mean? What is the exclamation mark? Means excitement or something? Yeah. Boom, boom. Yeah, name and children. Okay. Simple or complex. Okay, fine. Now we have the parser. If T is AST. Parser. Unbound module AST. Restart. What's the problem? Some modules don't have implementation. Unbound module AST. So AST over here. We have the library AST. Why does it not have the implementation? Let's look here. Some modules don't have implementation. Which ones? Why don't even you tell me which ones? You need to add the following field to the stanza. Modules without implementation, parser. What? Oh, wait, I don't have the implementation. That's right. Parser, ML. There we go. I was just writing this thing. Can I generate this though? Can I generate it from that? Create parser ML? Yes. Can I generate this signature with like underscores and stuff? No? Of course not. To do. My parser is something. Source and util. Like this. Of course I can generate. Create empty file. Yeah. That's what it did. Okay, so what is a parser? A parser is because that's the entirety of the AST basically, right? The parser is a data structure that is going to contain all of the different like rules. So we should be able, you know what? Let's actually start without the MLI. Maybe I will edit later instead. So we will have the rule. And the rule is the syntax definition, basically, right? So what is the syntax definition? Why do you parse if you could just compile instead? Compile what? You compile compiling includes parsing, right? So a rule has a name. A rule is something like this, you know? If I want to have the if I want to parse if A, then B, else C, right? Then this is a rule with name if, you know, and then we have like all of these different parts. Parts is a rule is a part list. You know, I'm going to have a module rule here. Type rule. Type T is rule. Column. Where part is either a keyword, or or a binding. Name. Name string optional. We can optionally give names to the parts of the syntax rule. Okay. Maybe I should add the test thing here immediately, kind of. Parser. The parser test. Parser. String option or option string is a longer way to write string. No. Optional one can be null. The non-optional one cannot be null. Right? Okay, so parser dot let's do this. Rules is rules is, so this is a list of rules, right? Parser rule list is just for example, right? For example, I want to be able to parse an if statement, right? Which is going to be this module rule is parser rule, and let and type rule is rule T. They're like a not really like a simpler way of writing that. I feel like I'm going to be doing that a lot. So have rule keyword if, and then wait, what? This expression should not be a constructor. The expected type is rule. Yes. Oh, yeah, right. This is a rule. Yeah. If rule. If rule is this. Name is if. Parts is that. Which is the keyword if. All right, so we have the keyword if. Then after the keyword if, we have binding to the then case. And then we have keyword, which is else. And then we have another binding to the else case, you know. I guess this can be inferred. And this should be like sum. Right? So this is how you define a syntax. We have if, then else, with two bindings, which means inner expressions. There's going to be something else. There was like the priorities. How would you create that? How would you program? You can have null or string. That's the nullable string. That's the same as optional. Yeah, sometimes you really want to have an option, a double option. This gives you more flexibility. It happens sometimes, maybe not very often, indeed. But even in languages that do that, that treat like you can have null or string, and that's the nullable string. That's the same as optional. Like even languages that do that, they still have a special syntax. Maybe instead of saying string option, you say like string question mark in TypeScript or on C#, right? In this case, we have the option instead of a question mark. Or we can have just completely untyped language like JavaScript, and then you don't need to worry about the types. Okay. We need some more. We need some more information, specifically because I want to have inner rules, right? So let's have tests. Let's have tests. Test. Test. So like for my Lexer, for example, the test was something like this. Test the source and then expected that, right? Something similar needs to happen here. But what is my expected stuff? My expected stuff is like the expected AST, you know? It's like the expected AST. I had a separate type for this, the expected token, which is like a simplified version. And probably will have something similar. Flow remarch. Flow remarch. Expected. Let's just have unit for now here. Let's just try coming up with a test first. For example, I will say yeah, I will copy paste this code too. So what I'm trying is to we record back traces. If I have a failure, then I put it to the error. So the actual tests, right? I'm going to test source. The source is going to be some string, sure. That's going to be the source. Which means that we have another rule, like for this to be parsed, right? For this to be parsed. For this to be parsed. For this to be parsed. For that to be parsed, I need another rule, which is going to be the function application rule. So like apply rule is a rule. Name is apply. Parts is this. So we have first the binding, where name is so first we supply the function, right, that I want to call, and then we supply the keyword opening bracket, which is a keyword, of course, and then we have the keyword closing bracket, and then we have another binding in between, which is the argument. So we have a function that we apply to an argument, right? What's the difference between modules and classes in OCaml? Nobody uses all classes in OCaml? Yeah. That's the difference, I guess. Not doing quantifiers? Not yet, not yet. Let me just start with the simple one, okay? I'm not going to write... Like, I think first I will do the same thing as I had before, and then we will add quantifiers and maybe like other features. And actually, I will change some things because previously all my rules. So like we had the priority. I was loud. Hello, Hari. Previously I had the priority on the entire rules, but now what I want. Well, I mean, I think I still want to have the priorities on the rules. Right? Like because here's the question, right? The function test has type source expected is applied to too many arguments. Source colon. There we go. So let's say that I have something like this. If f(x), then a else b, right? This should be parsed properly. And then we have another. Actually, I guess it's not going to be really. Or is it? Yeah, like if I have the function application which has the parentheses, then it doesn't really matter, I guess. Let's have the function application like in OCaml then, which is just function and argument without the parentheses. But then I will have the parentheses, you know, so I call this the scope rule, which is just scope, where parts is keyword opening bracket, and then the keyword closing bracket, and in between we have the binding. This one doesn't need a name, I guess. Our OCaml iteration times, they're supposed to be the best out of all the like languages with good types, I guess. So out of the Rust, Haskell, and OCaml, OCaml is like blazing fast to compile, basically. That's why I'm rewriting. Otherwise, I would not be rewriting at all. Or I would rewrite into Haskell, at least. Okay, so we have this. And we have these three rules. We have if rule, scope rule, and apply rule. Right? That's what we want to parse. Or rewrite in C. Yeah, and suffer. I don't know. C makes... even if the compile time is good in C, maybe, there is going to be a lot of time spent in other places. Like, I will need to spend some time crying, for example. Okay, so the thing is, right? If f(x), then a else b, right? And then, what should be this? Should this be parsed? You know? So if condition, then a else b, and then I have a function over here, right? Should this be parsed as function application? No, it should not. Why? Because the function application should have higher priority than the if, right? So this should not be parsed. This should not be parsed, is the idea. Unless we do the parentheses here, right? Because parentheses allow any... like this should be the binding that allows any priority inside, basically. So this should not be parsed. Okay. Hello, Gardienka. All right. So in order for that not to parse, we need to have priorities here, right? That's the idea. So when we have a binding should have the like what are the allowed priorities that go inside the binding, right? So priority, like priority is a priority. We call it priority filter, maybe, because it's not like it's not like the actual priority, but it will say that the priority of the inner expression should be less than or equal. I mean, I guess more than or equal than something else. So priority filter filter is going to be either more than priority or more greater than, or greater or equal. Just say greater. Greater or equal to priority. We can also only have we can work with just or equal, I guess, or just with greater, but I think it's better to have both of these things. So the priority itself is it can be an integer, but I like the floating point numbers more, I guess, so that we can have like more precise things in between. Maybe is there like a decimal in OCaml in the standard library? Probably not, right? We'll just use float here, it's fine. So that's what it is. So for example, for if, right, and then also the priority should be inside the rules. So the rules should have names and priorities. Priority is float. So it means that as when I'm parsing, so the bindings is basically corresponding to inner expressions. The inner expression should have the priority, which is either greater or equal than a specified one. So I only try to parse those rules that are like that are filtered, right? So we use this priority stuff. Yes, that makes sense, right? I'm having trouble with words though. Okay. So the if priority is priority. Let's just say this. Let priority be 1 in. So I must have a dot here for the float, right? So the oh wait, hold on. This is actually incorrect. Hold on. We have then case, we have else case, and we have also keyword then, and we also need to have the condition here, right? Condition. We have condition, then, and else. I think that's fine. So the condition should have the priority, which must be greater than priority. So this is the priority of the if specifically, right? Priority is greater than priority. Priority is greater than priority. So like for a lot of these rules, the priority is always like these are always going to be the same filters. So in the previous version of cast, I didn't even have this option to specify the priority filters of the bindings, but now I want to have that. So the grammar is the array of rules. Yeah, basically. I mean, it's going to be like it's going to be stored in a data structure, so it's like we're still going. The parser is still like linear, but that's basically the grammar. Yeah, like you have seen this before though. Why do you ask? Have here's the definition of the syntax, for example, that we had before. Have std syntax. So these are all the syntaxes, right? So this over here, for example, is if. If is if condition, then else, right? We had like the one without the else and everything. So we define the syntax, which is left associative and priority. I don't think I will have the associativity, because associativity means that like what can we have? Associativity is replaced with the priority filters of the bindings in this version, I think. But yeah, this is the syntax. It's just a list of these rules. The grammar is the list of rules, yes. And you can inject these rules while parsing, which makes it the extensible parser. Why do you write built-in? Built-in macro I think the better name for this is the core syntax. So there's like the difference between the core syntax and the library syntax. The core syntax is implemented in the compiler, so the compiler only knows how to compile the core syntax, and then you can extend the language with your own syntax, which then needs to be implemented through a macro. That's the difference. So because I was only given like the names, I need to like the compiler like we don't need to like these are corresponding to the built-ins in the compiler. And this, for example, the plus operator is just implemented through a macro, because the plus operator is just calling a function. So I don't need this to be a built-in. Okay, so we have this apply priority is greater than priority. So this over here, for example, right? Because applying a function is... This is actually not correct here, right? Because I want to be able to parse something like this, fxy. And this should be parsed as basically fxy, right? So it means that in the function application, the fx is the same rule, right? So the function here should be greater or equal. So because one of them is or equal and the other one is greater, this makes this a left associative thing. If the other one was the or equal, and if the second one was or equal and the first one was just greater, then it would be the right associative thing. So for the else, for the if then else, for example, right? So that I should be able to parse like else if, right? In order to parse else if, we say that this should be greater or equal. So the if expression is actually the right associative one, right? But inside of this, will parser catch the ambiguity if it exists? I guess depends what you mean. Like, for example, in the previous version, I could not specify the two, like, I could not specify the two syntaxes which start with the same keyword and have different priorities, because that would lead to ambiguity a little bit, right? I think I can lift that restriction. But we you just need to understand that the parser is like greedy. So if something can be parsed, then it's going to be parsed. So like we resolve the ambiguity by saying that it's always parsing something that if it can, like a regex, I guess, right? Is it possible to rename greater or equal to greater or equal, or maybe just GE? Yeah, maybe. I don't think GE is good, so let's just say the greater or equal instead. If you don't like the ek, we can also say we can say grek. Grek. GR. No, I don't like that. But yeah, it's weird that I was like shortening one thing but not the other. Let's just make it full. Priority is 1.0 in priority. So for example, the scope rule, on the other hand, is going to be a different one, right? Because we have the parentheses. So inside of the parentheses, we can have any expression of any priority. So the priority filter is actually going to be not even greater than or equal. This is going to be literally any. We are going to have the third type of a filter, which says any. We could have like instead greater than or equal than negative infinity, but I think that's better. I think that's better. So like inside of the parentheses, we basically reset the priorities and we can parse anything. And now what are the priorities? I just set this to 1, right? But basically the if the if has the priority of 1, then the apply should have the priority of 2, and the scope should have the priority of let's just make like 1 billion here, because that's probably the highest one. Annie, are you okay? Are you okay, Annie? Huh? Or go down the first valid rule. I don't like, no, going down the first valid rule is not correct. I mean, technically, I don't have the list of rules is not ordered, or at least it's not supposed to be ordered. So if there is ambiguity, then we should either report an error or resolve it in some way. For example, we like let's say that I have the syntax for if then else, and I had the syntax for just if then without the else branch, right? And then I also had the syntax which is like yeah, so I'll have like if A then B else C, right? We have this syntax. Then we also have if A then B syntax, and we also have A else C. For some reason we have this syntax, right? Let's say for some reason we have this. So should then if A then B else C be parsed as if A then B like this in the parentheses else C as 2 separate rules, or should it be parsed as a single one, right? That's the question. This gives you the ambiguity, and I think that the answer to this is that if I can continue, that I can continue, so we always use the first rule here, right? That's what means the greedy parser. It just parses the single definition until it cannot do any progress. So that's how we remove the ambiguity. Okay. Okay. Nice. Wait, what? Why does it not fail? Shouldn't this fail because I said I fail with to do? Does this not run this test? Which test is it? I thought the Dune test should run all the tests, no? Well, with high. This parser doesn't match any known test. Library. Oh, it's a library. That's why we need to call it a test. That's the reason. There you go. There you go. Okay. Okay, let's implement. Is it? I think this is all that I need. I think this is all that I need. And then later we can have like the quantifiers, so that the rule can contain like repeated things inside. All right, I need to have a break though, I think, for like 5 minutes. Now the very complicated algorithm, I think it's like after the several iterations that we had, actually not that difficult. But yeah. But yeah. Type rule is rule T. Okay. Okay, so we have several stages, right? I even have documented this before, kind of. It's not like the very good documentation, but yeah. Maybe, or maybe this was good enough. So we store the syntax definition in a tree-like data structure, in a tree, so that we can, yeah, we can do stuff. So let's have that. Let's have that. Can I move the module into like its own module? Or do I write everything in one file for now? I don't know. Have you seen the talk Diane Systems? No. No. Diane Systems. There's a security risk ahead. This one? The how and why of reinventing the wheel? Reinventing the wheel? Yeah. I'm pretty sure that this is the wheel that I have reinvented, but like the question is, what exactly is the kind of parser that I have? We have the parser that can be extended during parsing. And then we have the definitions in the list of these rules, basically. I don't know. I don't read much stuff, so I don't know. This probably has done before, for sure. Okay, so I will want to have a module. So the data structure that I store, right? So rule what do I call it? Like a rule set, for example. A rule set maybe is a good name for it. I was just calling it the syntax. So the syntax is like the list of rules, right? I just call it the rule set for now. Type T is rule set is rule set. For Solding's Lang port, at some point he added a feature to generate pictorial graphs of the program control flow. In that vein, do you think it would be a nice idea to have feature to generate a graph of the parsed syntax tree? But the syntax tree is not a graph, it's a tree, right? While the control flow in the program is not a tree, it's an actual graph. Like, as a tree is a very simple graph, which means that, like, you just print it in the terminal and you see it. You don't need to generate a picture for it, right? It's very simple to visualize the tree. Let me just go ahead and do that. Mix run github cast lang cast. Let me just do this so that I can refer to the old version of cast. I'll let it download. I've been exploring various functional programming languages for the last couple of months. What makes OCaml stand out compared to the more recent Beam-based languages? What are the most recent Beam-based languages? The Gleam? What is there else than Gleam? Gleam is basically OCaml, right? As far as I understand, Gleam is a simpler version even of OCaml. Elm is not the newer one. I mean, it's relatively new, I guess. Elm is not Beam-based at all. I don't know. Elixir, I don't like it because it's dynamically typed. Elixir types. Can you do types there? Type specs. There's like optional types, right? Or something. Kind of. Like maybe they have the types. I don't know. I didn't really try Elixir. Cannot tell much. Gleam looked okay, but like, I don't know why would I use Gleam instead of OCaml. New chat. Gleam or OCaml? OCaml. Why? Because Gleam is cute, but OCaml is the ancient warlock. Like, the only reason is to target the beam, right? Your GPT is weird. Why? Because it says my life would be 1,000 times easier with Rust, by the way. That's just true. Okay. What's this? You draw like that? Well, I mean, this is the semantics. Why would I want to draw like the and one while we are just parsing the AST, we don't have the semantics attached to the AST yet, right? The semantics has been attached when I convert it into like what I call the intermediate representation, which is like which knows the control flow patterns already. Watch a video here.
Foo.svg. There we go. So we have this, quotes around the intrinsics, but maybe that's fine. You know what I'm talking about?
How much of this do I need to watch?
Fine, because all of that is for debugging purposes anyway, right? So it's just like any program.
This graph sucks.
So control flow. I think
Yeah, I don't know.
just want to see the control.
Right there, he's showing it. I don't know. Well, what's the? I don't know what you want from me. Why is that good to have that? That was not even it was not even a graph. It was just a line. There wasn't even a tree.
So
Hello world. One syscall drop halt. What is that even? This also doesn't have anything to do with the AST. This is already, I mean, maybe this is the actual semantics of the program or something. What is one? I don't understand this. Oh, just a bubble. Okay, so we'll have the rule set. Rule set is the data structure which calls all the rules, right? So this is the data structure that holds a bunch of rules. This language is stack based, so that's just pushing one onto the stack. Hello, so we push this onto the stack, we push one onto the stack, we push one onto the stack, and we have a syscall with 3 arguments. What is the syscall? This is just an example. One is for write. Indexing your syscalls. Okay, fine. Anyway, I don't know. That's weird. I mean, maybe it makes sense. I just don't understand why do you want that. And this is the yeah. Why do you want that? Rule set. So rule set, we store the rules in a form of a tree, right? So we have a thing which is going to be called edge, right? We have edges in the trees where we say what's the next node. So we have nodes in the trees. We have so rule set is a tree which has the root node, you know, and we have the type node which is having the next, which is the list of edges. It's not exactly a list, but so this is how we represent a tree, basically, right? We have the node, and node can be connected to potentially other nodes. My point is, you could draw the graph of the AST tree for the stuff after it's parsed. Sure, but like once again, why do you draw it instead of looking at it in the terminal? It's just a tree. What's the reason to look at it? Just to have it as an image? Like, for example, this graph, the dependency graph that I'm generating here, right? This is supposed to be the acyclic graph. It's not a tree. So there is more reason for that, for example. Just dependency graph. See? So now we have the cast, which depends on the lexer. We have the parser and AST, and this depends on the lexer, right? This is my new graph now. For now. What the fuck is end in an edge? In OCaml, you specify multiple types recursively because edge contains a node and node contains an edge. Because I can only use the things that are previously declared otherwise, you know. So because this is a recursive one, we need to specify the two types at the same time, kind of. Otherwise, like we can do something like this: type t is t, and this is going to like override this one. Oh wait, this one is cyclic. Wait, what? Wait, can you say type foo is x is foo? Well, I guess maybe in the type definitions you can refer to itself. Yeah, but not to the the other types are only those that, like, if I say foo2 and I say type foo2 is unit, right? Then this doesn't work because this is not known yet. We parse the program like linearly, kind of. No camel. By the way, you use list again instead of array. This is not even going to be a list. This is not going to be a list. Because the edges are going to depend on, like, it's more like a map, right? Let me draw. Oh wait, hold on. My stuff actually failed to compile. Cannot wrap because it's not an executable. What? Weird. Okay, I guess we can go to the playground if I want to show something. So basically, we have the syntax tree, right? For example, in order to parse the if then else, we start with the root, right? This over here is root. Root means that I have not parsed anything yet. In order to parse if then else, we need to first go and parse the if. So the edge represents parsing something, parsing either a keyword or an inner value. So in this case, we go towards the if. So we have parsed if successfully. When we are in this node, we know that we have parsed if, right? Then in order to go further, we need to parse the condition, which is not a keyword, right? But an inner value. Let's have this in parentheses, for example, here. So when we're here, we have parsed if condition. And then after that, we need to parse the then keyword. After that, we need to parse the then, which is the then case, right? The actual value. So like this is how we represent the if then without the else, because there is no space anymore in this tree. So if I had another syntax, which is like yeah, so this corresponds to the syntax if condition in parentheses mean that it's like a value, not a keyword. Then, right? So this is corresponding to this syntax. And if I had also something like this, if I also had like if a like I don't know, some stupid syntax which doesn't make sense. Like let's have like an arrow here, for example. If A, then B, you know. So we have a actually never mind. These don't have names. These over here, they don't have names. Yeah, this is just some value, you know. That's what it is. So we have if value, just have a dot for it, then value, right? And if I have this syntax too, then we have if value, and then we have the keyword, which is like the punctuation in this case, and then we have another value. So like this is how we represent this tree, which is able to parse both this and that syntax. You should use infinite canvas. The ASprite doesn't support that, unfortunately. There is some online ones which I could use, I guess. Why am I making Parser in OCaml? For fun, of course. Why else? Syntax is not important, only semantics matters. I agree. But we still want to write program that is easy to read. I could just have a Lisp, yes. Which is basically what we are going to convert the syntax rules into. So that's why the AST is this simple one. But yeah, syntax is not important. We are not trying to like choose the syntax. We're just making the parser. Like you still need to parse something. You need to still parse a Lisp if you have a Lisp, right? It's just a lot simpler to parse. What about assembly syntax? You can have assembly syntax if you want to. Like this is supposed to be generic enough, or at least my language. We can have it parse the assembly too if you want to. But like, what do you mean? What about assembly syntax? What's your question? You can parse assembly syntax. It's simple to parse, sure. But why would I do that? I'm not trying to make an assembler. So yeah, we have the edge. So this is not a list. This is basically like a hash table. I need to like remind myself how do hash tables work though. We have hash table make. Yeah. Is it parse easy to read also? There is no order of precedence in assembly. It's easy to read if you care about reading assembly. Like, why have you actually written a big program in assembly? It's not readable when like a single like if you look at a single like a 5-line section of assembly, you can read it, yes, but you need to understand the entirety of the program and not just those 5 lines. Sure, yes, assembly syntax is simple. C language is simple. I don't want to use that still because it is too simple. Brainfuck is simple. Do you make hash table T or like hash table make? hash table make is making the type that is hashed. Yeah. Yeah, I think I think this is it. So we have a hash table over. Wait, do we have a hash set in OCaml? So it's a table from like the type of the edge, which is either a keyword or a value, basically. Right? Type edge type is either a keyword of string or a value. That's literally it. You're talking about the syntax operation, operands list, and the only operation and only one operation per line, like a linear list with no parentheses. Okay, sure. What's the question? I don't want to write a language like that because that's stupid, I think. Yes, sure, it's simple. But what's the advantage of that? There is no advantage. The simplicity is disadvantage in this case, in my opinion. And like basically no one writes assembly anyway, so everyone is agreeing with that, right? Is there a language like assembly which is like high level without any nestiness that people actually use? So the edge type should be like a module edge type. So we have hash table make edge type, right? So this would be an edge map. So we say type a edge map is, we say module edge map is, wait, there's map and then there is the hash map. Hash map is just hash, map is ordered map, right? Yes, this is ordered types. I don't, yeah, we can do a hash table make for the edge type. So this needs the type T. Type T is that. And then have the, we need to have to specify value hash and equal. It would be nice if this was like auto-completed by the LSP. Like, what are the things that need to be here? This is me basically implementing a trait for this type, right? Can I generate the equivalent hash here? What was between the node and an edge? Have you ever seen trees? The node is a node, and a tree is the connection between two nodes, right? That's the difference. Specifically in my AST. Yeah, I guess we can, I mean, technically, I guess you can just represent the edge as just the node, right? Because it only goes in one direction, like that. Yeah, sure. Yeah, you can do that. Yeah. Maybe I will do that. We'll see. So I want to write a deriver. This is where I need to try the ppx, right? Or some stuff, maybe. How to derive equal and hash in OCaml. We can use structural equality in this case, right? But what about the hashing? Use ppx deriving. Add to Dune, preprocess. And then we have deriving egg hash. You will get equal and hash. There we go. So to the Dune, I need to add preprocess. Library ppx deriving show is not found. Which I don't need it, I think. I just want to derive the egg and hash. ppx deriving. Oh, so this means that I need to have a library called ppx deriving, right? ppx deriving. Is that like a built-in library? No. ppx deriving. Deriving is library for simplifying time-driven code generation in OCaml. Deriving includes a set of usage plugins. Okay, so act, show, ord. So like I can generate all of these. Yeah, and I want to like eventually to figure out how to make my own derivers. Dune's PPS directive allows faster preprocessing by linking the specified preprocessors into a single executable. Use deriving, only one modification is needed. You need to require via OCaml find the package corresponding to the deriving plugin. This will both engage the syntax extension and link in the runtime components of the deriving plugin, if any. For example, if you're using OCaml build, add the following to the tags. With Dune, you should add preprocess. I added preprocess, but like I need to install this. Yeah, we need to install it from the OPAM, right? Which I'm not using. I'm using Nix, so we instead add it like over here something, right? ppx deriving, maybe it's just like that. Yeah, that's exactly what it is. All right, good. I want to have it in a separate list here. Because this is the dependencies for the actual code. Library ppx deriving hash is not found. So deriving egg was found. This one was found. Is that right? Library ppx lib ast not found. Wait, what? Next caster writing Nix? Nah. Like it has the dependencies basically, right? In the OPAM. Where do I see the dependencies? Oh wait, hold on. What? Dry can be installed with OPAM. OPAM. It doesn't even link to the package. Packages. Search. ppx. Deriving. Drive. Wait, what? There's derivers. It's ppx deriving. Oh, there it is. Yeah, so dependencies are these: ppx lib, ppx derivers. Hold on. Why is it weird like that? ppx lib ast not found. Okay. I think, like, why isn't Nix doing this for me? ppx lib? That the one? Yeah, I don't know. I feel like it should automatically install the transitive dependencies. Or maybe it installed it. Maybe I'm not understanding what's happening here. Maybe I didn't reload here properly. No. Okay. Yes. What about the deriving hash? So the deriving hash is still not found though. Because there is no hash here. Because the thing lied to me. There is no hash. There's just ACK, ORD, enum, iter, map, fold. Okay, that makes sense. Let me actually try, maybe, like, I feel like this should be installed automatically transitively. Maybe I just didn't reload here. No, this says that... No, hold on, this says the hash still. How do you comment? Like that? Yeah, this says ppx lib. Yeah, I don't know. Maybe Nix is weird. I feel like that's a bug, maybe. Alright. Let's not make that. Just make unit for now here. Okay, yeah, so like this compiles, and I can derive the equal, right? Type T. Okay, there is no auto completion for that, right? Deriving, so just type and then deriving, right? Deriving ACK. Like this. Alright. If I say deriving show, it will say that show is not a supported type deriving generator. ppx-lib deriving. So the deriving itself comes from the ppx-lib, and then the deriving package itself is specifying how to derive the equal and how to derive the show, right? So for each of those, we say that each of the derivers is going to be like there. Okay. Is it hard to write my own deriver? Maybe there is a package deriving hash. There is. There we go. ppx deriving hash. ppx deriving hash. Or is it like underscore hash? Because it's in a package like that. ppx deriving hash is undefined. Hold on. It's not in Nix. Yeah, a lot of the ppx packages are also not in Nix. Like the OCaml people, they just don't use Nix, right? I don't know. I thought like Eduardo uses Nix. No? Like the package manager. Does he not? There is no thing like that. Okay. Well, I mean, I can install it though. It's not that difficult. Check with low stars, disgusting. Yeah, I mean, I already did like some stuff manually here, right? Like I built some from the source here. I can just do another one. Let's build the ppx deriving hash here. ppx deriving hash. I like it. Yeah, like this is just fetching from the GitHub, not from the stuff. But I guess it's fine. We just do from the GitHub here. I don't know if it can. We can write a Nix thing which downloads from. There is the OCaml to Nix, right? And I need to figure out how that works. 013 is the version. Build inputs. We'll see. Have I ever tried Manjaro Linux? Yes, I tried it. I think Arch is better than Manjaro. Why would you? I don't know why you use Manjaro if there is Arch. I mean, I understand the idea, but then like it just didn't work for me. It broke like the second day I installed it, but Arch didn't. I don't remember the details though. I have like had problems with Ubuntu similarly to Manjaro. Kind of, it just didn't work for some weird reason. I don't know about package ppx deriving hash. Wait, what? Do they not call it ppx deriving hash? Source? Dune? Package ppx deriving hash? Wait, it's a library. Build Dune package. ppx deriving hash. Wait, what? It's not. It was supposed to tell me that the SHA is not there. No, it's not correct. ppx deriving hash. I know what package this. Source. Yeah, this is a different one. Wait, what? Wait, oh, wait, it's a bug. I think this is a bug in Nix. Hold on. I think I just found a bug in Nix. Maybe it's because the SHA, I just copy pasted the SHA from here. So it's like looking in the Nix store that this SHA already exists. So it assumes that I have already downloaded this, even although the owner and the repository is different. Is that what's happening here? I feel like that's what's happening here. I think that's a bug. Did I report it? This is the correct SHA. Like, it didn't even try to download the source, is the problem. ppx lib meta quote. Yeah, so I need to do ppx lib here as the input, right? Anything else? ppx deriving. Yeah, I guess this is what the OCaml to Nix is supposed to do, right? OCaml, turn OCaml based projects into Nix derivations. Automatically resolve OCaml and system dependencies. Yeah. Like, so that I don't do this manually. Alright, maybe next time. Unbound value pexp function cases. Do I need to install something like pexp? Is that also a library? Version issue? What do you mean? PPX deriving hash line 100 characters 5 says that PXP function cases is unbound value. So it doesn't compile. The PPX deriving hash. PI passing 031. You think this is a version issue? What is this? You say the version of the PPX deriving specifically, right? That's the problem here, because this library has a different version in Nix than the actual dependency of this crate. Is this specified though? Like, let me see. Like, maybe I try opam to Nix or PPX lib, one of the two. If they mismatch, will I be able to use them in the project? Dune project. So yeah, you depend on, yeah, they just say more than or equal 0.36 and more than 5.0 of the PPX deriving here. The mess that is OCaml macro system, you think it's a mess? I never tried it, I'm just interested to trying it out here. Maybe I want to try to write my own deriver too. There's just like the dependency management problem. All right, let's try opam to Nix then. Quick start. Over here. OPAM is a source-based package manager for OCaml. And then we do this. Introduction of OCaml Nix. If you're familiar with Nix, you might have noticed it doesn't have any of the aforementioned problems. Nix doesn't have problems. Got it. All right. OCaml, OPAM into Nix structures using a OPAM file format. In the following, we assume you'll have Nix installed and using flakes. Yes. All right. Simple package. Get started. Do this. We'll create flake Nix for you. Something. Inspirations and alternatives. OPAM Nix wouldn't be possible without OPAM and OPAM file format. It uses them directly to implement some of the parts in Nix. It's similar to Crate to Nix, Cabal to Nix, and Poetry to Nix. OPAM 2 Nix is the original. It requires committing the generated files into the repository, doesn't integrate available flakes, and is not as flexible. OPAM Nix integration is quite similar to OPAM Nix. However, it's not flexible since it doesn't allow to import OPAM switches or easily multiple packages. Is there like a simple example where I just build the GitHub repository using OPAM Nix? This is too much words. Anyone uses Nix in OCaml at the same time? I can see what's in this. There's a template, right? Examples. Coq or OCaml LSP. So this is just yeah. So they just fetch from the GitHub the OCaml LSP and they just build it, right? So that's the source, and they just build OPAM project with this source. OCaml base compiler is star. So like this specifies the dependency on the base compiler or something. Fetch submodules true. Yeah, this maybe this is what I should use. Okay, let's try that. This sounds easy. I just don't need to specify the dependencies manually, right? We add the input, which is the OPAM nix. OPAM nix lib system. Okay, so we just say build OPAM project. His inputs nix puts OPAM nix dot lib dot system. He's also using ppx lib. I don't know how about hash though. Yeah, I have already installed like two things. The OCaml index for some reason is also not in the Nix packages, so I needed to like figure out how to do that myself somehow. I'm just it's the same as it's part of the Merlin projects technically. So we do this, and then ppx driving hash. We just say build OPAM project, which takes an empty set. Is there like a documentation for the API though of the OPAM nix? There is documentation. Package terminology. I'm interested in build. Oh, oh wait. So like the it's like the library itself. Build OPAM project is the OPAM nix library itself. Okay. Query. Repository. OPAM nix package is just an nix package based derivation. Would have taken 2 minutes writing manual hash. I never tried. I mean, I want to know how to do both. I want to know how to import the dependencies from the OPAM easily, right? Which I guess would be easier if I was using OPAM instead of Nix, I guess, right? But there was some problem, and I was trying to do that with the OCaml. So that might require also changing the like moving to away from Nix OS. Or at least working in a Docker container. Or I can just figure out how to do it with Nix, which is better. Okay, you know what? I'm too lazy to read this. Let's just use it as the example. So we have a build June project. We have the empty set as an argument in this example. And then I have the source, which is just the fetch from GitHub, which I already have here. Right, so we just fetch from GitHub. Let source be that. In build OPAM project source. And then there's also the OCaml base compiler. Is that all that I need? Let's try. It says version is not there. Yeah, so now I need to actually specify the version. The ppx deriving hash has version 013. Same exact problem as you trying to run OPAM. That was the problem when I was trying to use OPAM itself. And you can just nixenv nixos bubble wrap. But I did install the bubble wrap. And it didn't fix for me, right? There was some other issue later, I think. I don't remember. What exactly was the problem? Evaluating native build inputs. Attempt to call. Over here. And to call something which is not a function but a set. Beautiful. Scope. Oh wait, scope is build OCaml project source. Why did they call it scope? That's so weird. Yeah, just build OCaml project. Hold on, let me just try this actually. This is building the OCaml LSP from source, right? This is building OCaml LSP from source. You know, some stuff. You know, test is that. And then I want to, let's say, install, not this, I want to install the test. Is this going to work? Yeah, OPAM-Nix, this is like inputs, OPAM-Nix lib system, just so that it's exactly the same. Nix packages is puts. I just want to see that their example actually works. So this is downloading the OCaml LSP and trying to build it, right? Is it downloading still? Is it building? Is OCaml LSP a big project? It says fetching source, so it's downloading right now. Yeah. Oh, it only started downloading right now. Okay, yeah. Copying and then building. But you didn't DRM reload after adding bubble wrap? Oh, is that so? Are you sure? I mean, usually it reloads automatically when you just press enter in the terminal. Did it say hello from cast dev shell? Because if it did, then it's basically the RAM was reloaded. Oh, it's because I'm doing this like twice, because the VS Code extension is trying to do that too. Okay, that's fine. Can I stop the RAM extension here? Reset reload? No. Waiting for locks. OCaml LSP is not that fast to... I think it still is downloading it, though. Is it? Element 3 of native build inputs for next shell. So it doesn't work. The example doesn't work. Right? Or what happened? So this works. This didn't do anything. If I do test, then it says dependency is not a valid type. Element 3. Can I hide this? OCaml platform is using the package manager. Can I go to the settings of the OCaml platform so that it doesn't like show me this? I don't know. Depends is not a valid type. Element 3. But I am just saying that, right? Oh, wait. Inherit. There you go. That's the difference. Inherit, and this is the thing. And to build a OCaml project with a quote, whatever that means. So build a OCaml project is this dot build a OCaml project with a quote for some reason, right? That's what is missing. Let's try the deriving hash again. Maybe, but I don't know why the example is not working. Hello, Denny D. Oh, Denny Andos. Why the OCaml LSP couldn't be built though? That's weird. Do you remember me? No, not really. Hello, welcome back. How are you doing? Did I remember you? What did you do last time? Whether it's Rust stream or OCaml stream, you can guarantee it will be 50% next stream. This not happens very often. It's only when I setting these things up. And it's only happening one time, right? Setting thing up. Yeah, it's dependency is not of a valid type again. So like it's the same issue as in this example. So their example doesn't work. Issues. Element 3. Maybe it's because the Nix packages version is different for some reason. That could be the case. Because there are some breaking changes in the Nix version. Let me just see the issues here. Failing to install package. Well, I mean, it's not even going to the installation, right? South Korean, that's a hint. I don't know. Did we do something together? In South Korea? But I never been to South Korea. And my major programming language is Haskell. Did you change your name? No? Then I don't remember, you know. When did I last see you? A year ago? You expect me to remember you from 1 year ago or something? I need to stop wasting time on this, right? We need to write the driver ourselves. Just write the driver ourselves. No, but I need to figure it out. Apply to Nix. Examples 2 weeks ago. Maybe I should try something from 2 weeks ago, not from 5 months ago. Like FramaC. Right? Default package is this FramaC. FramaC is scope overlay, scope overlay. Oh wait, is there like an overlay? Nix LD flags. Oh, look at this expat. Is that the issue that I had? They have something here. for the LD flags or something somehow. Maybe that was needed for my OPAM to work. Scope, query to scope. Pharmacy. Override scope. Overlay. Wait, so query to scope? Hold on, maybe like the documentation. Query to scope. Wrappers, packages, overlays, resolve args, query into scope. Turns a query into scope. Special value of star can be passed to a version of the query to let OPAM figure out the latest version of the package. Examples, query to scope. So like this is the OCaml package, and this is the package that I get as a result. Okay. Build a package from this using all same defaults. Isn't this all that I need then? Hold on. Hold on a second. Let's just try following the documentation instead of examples. PPX deriving hash is query to scope. I don't know. Steps from OPAM. Let's just call it OPAM. OPAM, and then we have a PPX deriving hash is star. Just use the latest version, right? And then over here, just say opam.ppx deriving hash. Is that going to work? Query to scope is the thing from opamnix. Let's just say over here instead that opamnix is this library for the system. All right, let's try. What if it's just going to work? Because then this is very simple, right? I just specify my dependencies of the OPAM here. Actually, I can make my project the OPAM project and then like install the dependencies with Nix somehow, so that it works, so that this works with both OPAM and Nix then, right? Because that's just a single line. It's easy. It could be. I think it's building it right now into VS Code. I should probably. Maybe I should like close the VS Code when I'm changing my flake like this. Oh, it's using my CPU right now. To all the 100%. It's building. Is wait, CC1? Was it actually like invoking the C compiler to build that stuff? OCaml run? OCaml used to transpile to C? Is this like the old version or like maybe hold on. PPX deriving hash. I mean, this is from we have something from 3 months ago, right? Yeah, the latest release was on March 21. It's not that old, right? It's fine. LD, CC1, like there's some C compilation happening right now. Depends on PPX sleep and PPX deriving. I don't know. Maybe I'm compiling the OCaml or something. It's fine, I'll wait. It's okay. OCaml OCaml-opt.opt. Okay. Let me just assume that it's there, you know? Let's while we're waiting. Let's continue the parser. So I have the edge like that, right? This is going to be deriving the hash too, basically, right? By the way, equal is already derived, so this can be deleted, right? And if hash is a to-do, then I should be able to do that. So that should actually work. The value lid of the type ppx long ident ast long ident ppx deriving .cppo.ml failed. Beautiful. It's actually like the ppx deriving that failed to compile, not ppx deriving hash. It's time to manually implement hash. Yeah, maybe. Maybe. Maybe it is. Fine, let's manually implement hash. I'll try to do that later though, I guess. To figure this out. Oh, Eduardo's Nix template. Yeah, that's a good idea, actually. Try Eduardo's. Try to see how Eduardo is doing stuff. Like, he's actually using Nix, right? Like, maybe like Teika? Where's Teika? Oh, it's not. I don't want just GitHub Teika lang Teika. We can look here, right? Flake Nix. There is no OPAM project, right? So the dependencies are here, but he's not using any dependencies. Maybe he's not using the ppx. Inherit Teika. Packages, call package. Nix. Oh wait, there's .nix over here. Shell. So we have the OCaml format, OCaml LSP, and utop. And then we also have these menher lib. So these are the actual like the things, right? The ppx driving. So maybe she's just using all of the things that are already packaged in Nix. I don't see any like any packages that are not in the Nix, basically, right? But there are the things in the in OPAM that are not in Nix, like the deriving hash, for example, right? So he's not just using any of those.
So, I made a template to do OCaml development using Nix. Nix the package manager, not the operating system. To use it, you first install Nix, install your env, enable flakes. Now you can clone the project, open the project on VS Code, install the recommended extensions, allow, restart, and now you should be ready to build the project, and the editor should be working. That's it. If you want to find out more, it's going to be written down. So, I made a template to do OCaml development using Nix. Nix the package manager.
Is there like a description for the shorts?
To use it, you first install Nix, install your env, enable flakes. Now you can.
But I mean, okay, so here's the thing, right? Is there like OPAM to Nix or something here? I feel like I have already did this, right? I know how to install a dependency if it is already packaged in Nix, right? Although over here, look at this, JSON RPC, right? So we actually fetch from the GitHub OCaml LSP, right? So something is happening here. OCaml packages 5.1 is this override scope, OCaml LSP. So like it actually is trying to yeah, it's like patching the OCaml LSP to use the newer version or something here. And that's, yeah, so like he only like changes the OCaml LSP here. But the problem is that, so he's not using opam to nix. Like, I can also do that, but that means that I need to manually define all of the dependencies, right? I already did that for the Dune depths, for example, or for a camel index. Like, but this, something like this, where it like downloads the ppx driving hash, looks at the, it just looks at the opam project and figure out the dependencies from there automatically. That would be better, because that's less manual work. Like, for example, the Dune depths, this one depends on cmd liner and sexp lib from OCaml, right? But this is already defined there technically in the opam. Okay, let's just ignore. And for now, write the hash manually. How do you usually write a hash? How do you usually derive a hash, actually? I can use an ordered map too. Like, I guess the easiest way actually is to use the ordered map. You know what? Let's derive the ord. Right? LSP support is there. So there we go. We have that. And I don't do the hash. I will instead just do the map, right? Sure. I mean, you are like, I guess functional programmers, they just prefer to use maps instead of hash tables. Well, a hash table uses interior mutability, where map is actually functional and like persistent data structure, maybe, right? Hold on, OCaml hash table. Is that so? Or is that not so? Because like, what's the thing, right? So we create the random, which has like stuff. Yeah, there's like the copy. Return the copy of the given hash table, right? So you need to explicitly copy. And yeah, for example, the function that is add is just using the table key and value, and just returns the unit. It doesn't return a new thing, right? Where if I look at the module map, probably, how do I go to the module map? Map s? Is there like a normal module map? Oh, this is the output signature of the functor map s, right? So the signature is going to be we add key value into the map and we get a new map, right? So yeah, that's the difference. Jane Street core has the rhyming hash. Yeah, but maybe I should use map just so that the data structure is persistent and more in line with the functional programming, right? Instead of use, so like that's the difference. The API is completely different. This one is immutable data structure. The hash table is mutable. Let's just do that. That's fine. Probably. Maybe I can have a like a to do here. Maybe hash map. Like, I don't know if it actually matters, like, performance-wise. Not for the parser, at least. Probably. Okay, so we have a edge map. Is edge map t, right? We just, I guess in this case I just don't do the alias. Edge map t. So from the edge we have the nodes, right? So these are the next nodes, like that. That's my rule set. Okay, nice. So we have keyword or value that is expected when I traverse the edge. Yeah. So what is my API here? Let's see. I want to be able to say so initialize is the empty rule set. Do I want this to be mutable or immutable? I don't know. Let's I don't know. Let's do the immutable stuff. Fine. So we just say empty. So empty is the rule set, which is the one where root is a node, where next is edge map empty, right? Like this. So we cannot parse anything. And then I want to say that add a rule to the rule set. So we have a rule set, and it gives me the new rule set, right? So this is a function from rule and rule set into the new one where root is merge rule set dot root. I guess not merge, like something like insert. And rule is a rule, yeah, insert a rule set, a root, the rule dot parts, something like that. So what's insert though here? Insert rule parts. Let's make it like an inner one. Insert parts into node. So I will return the new node, right? Parts is the rule part list, and node is node. Return node. Okay. So this is like the remaining parts that we need to add, right? I can basically and then over here I do something like match parts with, let's do parts struct, right? So it's either an empty list or like the first part and the rest, right? That's what it is. So if it's an empty one, and I am so if it's an empty one, it means that I have already reached the target destination of the node, the target destination, yeah. In this case, I say that this node, so every node is potentially the terminal node, which corresponds to a concrete rule, right? So every node is potentially terminal, which has the optional rule that it corresponds to. So originally terminal is none, and like this. Root it is node.empty. Module node is struct empty node is that. Okay, and then so in this case, this is the node that I have inserted to, right? I say that if a node dot terminal is some, then we have a conflict. So because we cannot have two syntax definitions that are exactly equal, we must have distinct syntax definitions. So if need to do a match, there is not any flat in OCaml. All right. match node dot. I'm wondering actually why. Hold on. OCaml if let. Like, wasn't there a allow if let syntax? There is a proposal for that. This is closed. Why? Because it was opened with no activity, of course. It's not completed. Empty parts is allowed. This is basically the loop. Insert is the loop. And this is me finishing the loop. So node terminal with some existing. So in this case, I just fail with such recursion, much functional. Yeah, it is. So that's what I need to do. Yeah. If it's none, then fail with to do with to do. Okay. So if we have an existing rule that corresponds to this node, then we should say fail with X string. I made this thing, which is using the printf stuff. So we just say fail with duplicate rule %a and %a, where I print the rule and existing, and I say rule print the current rule. The current rule that I'm inserting, the existing rule. Print is a function which takes formatter, and a rule returns unit. So I just say something like fprintf fmt. Let's just say %s. Let's just print the rule's name here. It could also print the parts, but maybe we just have the names for now. Okay, and then I say so if none, this means that I need to actually make this rule this node terminal. So I return the new node, which how do I do this? Node with terminal. Like, how do you extend? OCaml extend syntax. Extending the syntax of OCaml. Wait, you can extend the syntax of OCaml? What is this? Extend record. It's not called extension, right? Record update, maybe? Update record field value. Records. Functional update syntax. Functional updates. Yeah, it is with. Wait. Okay. It is with. Why don't I have the auto-completion here then? Because the language server is stupid? Okay, fine. Terminal is some rule. Here we go. So I was writing it correctly already. So we just set the terminal to be the current rule that I'm adding, right? This is when I finished, right? And then if I say that we have the first part and then the rest parts, right? So once again, the part is either a keyword or a binding. If it's so, I need to construct the edge here first. Wait. Edge map, edge type. Yeah, I don't need the edge, right? Edge is the edge type.t. Yeah. So first I need to say edge is edge type, which is going to be match first, like this. So if it's a keyword, then I say that it is the keyword, right? And if it's a binding, I don't care about like the specifics of the binding. This is just the value. Like that. Which means that binding maybe should be like inner value. Like, why did I call it binding? Let's do it value. Okay. So this is my edge. And then I need to basically traverse this edge. It might already be in the node next edges, right? So we have this edge map. So is there like an edge map dot... There's an edge map update. Update returns the map containing the same bindings as M, except for the binding of key. Update is, this is the existing entry and this is the new entry. Update, is there like the one I want the one that takes the function a option into a, I guess, because I must ensure that it exists. What are the other fields here? Merge of list, singleton, split, union, update. Maybe it's just update. I mean, there's add, but add might, like, what does add do if it already exists? The previous binding of key disappears. Yes, I don't want it to disappear. I want to merge them. But merge is merging the two maps. I don't have one map. Update. Okay, fine. So update is a thing that takes the edge type, right? So so I update the edge. I update the edge. I have the function and I have the node.next, right? So I just return node with next be equal to that, right? And this is how I merge. Merge node, merge, just merge, where merge is a function which takes node option, returns node option function. So like this is the current one, right? And I should always return the sum here, sum result, where result is let's make it simpler actually. So if it's let's do yeah, let's just do match current. If it was none, this is the simple one, right? Because then I just need to create the new one from scratch, which will be node empty, right? And I always do the sum. If it is, yeah, whatever. And if it's sum existing, then I need to merge them, right? I need to merge them. Sum existing. Just existing, whatever. We just do this. Because for now I don't actually add anything. We just go into this node. No, we don't go into this node, right? In order to merge this, hold on. Result is this. We return some result, right? But so this is me just going to the next node. Merge. I shouldn't call it. Should call it like next. Something. Yo, Code Red Games. Thanks for the raid. Hi. Robert Pattinson is here, of course. How are you doing? I'm writing some OCaml today. Rewriting my programming language parser. Okay, naming is difficult. Basically, I go to this node. Let's call it merge next. So like, basically, I traverse a single edge, and then I need to insert. Then I need to, over here, I need to insert the rest of the rules into this next node. That's what I need to do. Which means that this function is also recursive. There you go. This code is hard to read for me. It's relatively easy. Maybe like if I did it in the mutable way instead of functional way. I don't know. Let's keep it like that for now. Most readable OCaml code. How to make this more readable? Or is it just like a skill issue? Like I understand this, but maybe at least the naming could be changed. So insert, I mean, I think this makes sense, right? I insert the parts into the node. I get the new node as a result. If it's empty, this over here is simple. This over here is not really. So okay, edge is this. This is simple. But this over here is a little weird, right? Because, so I'm updating the going up the edge. I mean, it's relatively simple here. Looks very nested. Okay, how do I make it less nested then? I don't know, let's not think about it too much. This looks fine. Add comments. What should the comment even say though? Should I write like the Rust code in the comment to make it more easy to understand? Okay, let's try this in the parser though. Let's just try to add the rules, right? So that we don't panic or something. So in the test, I will say rules rule list, right? How about yeah, I want to do this. Let rule set parser rule set t is copy the code into comments for maximum readability. Yeah. So rule set is me converting this rule list into the actual rule set, like the actual data structure that holds them. So this would be list.fold. List fold using parser a rule set add. This has it in the other order though, so we should have like function. Yeah, because it has the accumulator first. Maybe some other function. Hold on, list. Fold. There's fold left 2. Fold left map. Fold right. Oh, I can just do fold right, I guess. Fold right. A rule set. Add. And then the list, which is the rules. And then the beginning, which would be parser rule set empty, right? There you go. So this is just how I construct the rule set out of these rules. I just add all of them together. You openly are making comments. If you don't add comments, sure. So we have the rule set. Is this going to like calculate it actually? Exception to do. Because there's the to do here, right? Yeah, I guess print exception true then needs to happen like somewhere over here. Right. Wait, what? No, there is still a to do. How do I get the how do I get the thing? How do I get the thing? OCaml backtrace is 1. Record backtrace is set to true. If I comment this out, then yeah, so like it's literally this code. So this code is trying to be ran, and so but didn't I say print backtrace here? There's just failure to do without the stack trace. Why not? Let's say create rule set like that then, and then I will. But I wanted to use in the tests, right? I mean, I can make this from scratch. Wait a second. Hold on. This is still failure to do without the stack trace. The hack for early return, try with exception, is terrible because it gets rid of the stack traces. Hello? That's what I need to do. OCaml run parameters B, right? But isn't that supposed to have the same effect as this? OCaml run parameters B. Let's do that. Wait, why were you trying to download something? Okay. Yeah, oh, okay, over here. Initializing the parser. Wait, isn't this even been called? Oh, it's not even being. I see. I understand because this is not like this is just a module being initialized, right? So it works before the thing. Yeah, that makes sense. Yeah. But I don't call this. Just call function into fail with to do. Function into fail with to do. But this function is supposed to be the source, like that, right? And then we have it. Okay. It doesn't even like go to the line properly because it says this and then inlined line 48. Line 48 over here. Like, why can you get rid of the inline so that I can actually go to this thing from VS Code? What does it even mean inlined? That's stupid. Okay. Yep. Can I just say rule set though then? Rule set is that. And we have an exception to do. To do test. To do test. Okay, yeah. So like this actually successfully worked. Okay. All right. I feel like I'm almost there. The data structure is going to have some more data in it, but other than that, it's basically there. So let's have the function for the initializing, the parser. The parser is just that. What is the parser? The parser is going to have the I think the mutable rule set. And over here we have a rule set by default. Yeah, like so the parser is like the mutable one. I think that's fine. The rule set is immutable. Okay. Rule set empty. Okay, and then when I say parse, yeah, I can add rule to the parser, which will be rule into parser, right? Which will be fun rule into fun rule parser into parser with rule set is rule set add rule to the parser rule set, right? Like this. Expression shouldn't be record. Yeah, not this. I say parser dot rule set assign that, right? If I do it this way. Okay. I like these arrows going left and right. And by like it, I mean I hate it. Can I make sure that this is on the other line? Can I change the formatter so that it like always makes this be on a new line? I guess I don't always want that. Okay. Add a comment. Maybe I actually initialize with the rule set. Type rule set. It's rule set E. Down. Okay, so in the test, we have the rule set, right? And then I initialize the parser over here. So I say let parser be parser initialize using the rule set. Okay. Adding rules, this is for like dynamically adding them. Maybe. something something parse is this. Okay, so I want to parse the source here, right? We have the source similarly to lecture. Yeah, I just want to do that. I say that source type source instead of a string is that, right? And then we have parser. Parse the source with the parser. This is the AST, right? Doesn't show me the line where the actual exception is thrown. Beautiful. I mean, it's inside this, right? Because there's a to do here. Okay, so we have the function, source, and parser. Bye, Nigel, bye. So in order to parse, I need the lexer, right? So lexer is lexer initialize lexer default rules source. Okay. Oh, wait, hold on. Parser parse the source. Yes. I feel like there should just be a maybe parser is not like even a thing. Well, we'll see. So I have the rule set, and the rule set can parse the stuff given the lexer, which is basically an iterator of tokens, right? So yeah, I say yeah. I think the API should be just like the API should instead be like this, just function parse, which is given the source to our, we return the AST. Given the source and the rule set, we get the AST. Do that. Sure, AST.t, fine. Function source rule set. So and this is where we just have the implementation, right? So I just call parse impl. Parse impl rule set lexer. Yes, I think that's it. So then we have the parse impl is a function which is taking the rule set lexer. Wait, I don't have lexer t. Lexer t and gives me AST. Unbound type constructor. Restart language server. Are you stupid? Lexer has t inside. Oh, because the MLI. Okay, because I have the actual thing. Yeah, we have yeah, not type lexer. Type T is equal to lexer. Is that possible to do? It is. Okay, so we have a rule set and we have the lexer, right? So we need to um parse one rule set lexer into AST. Think here. So when I parse one, I say what my current node is, right? Let impl. So we have the recursive impl, which is the function from the node, which is a rule set node into this returns AST. So I just call the function, this implementation with the rule set root, right? So we start at the root, and then we go into look at the next token, right? So yeah, we basically match lexer peak, right, with, and the language server cannot do anything for me. This is annoying. Hold on, maybe there is something like that. OCaml, OCaml, missing match cases, LSP, something, something. Like, like if I do this, but then this is exhaustive, right? Let's just do this, I guess. Peak is that. Peak is lexer peak, right? And then I can do peak, and then I can destruct it. Okay, so this is actually a spend one, right? So I actually do peak dot value, and then I destruct that. Match type error? What? It actually... Wait, what? Okay, if I say let value be peak value, then I say value, then I cannot type annotate. Is this stupid? Is this language stupid? AST token. Why is it AST token? AST doesn't even have the token. There is no destructuring here. This is supposed to be lexer token, not AST token. Value. It does not want to destruct this. Okay, whatever. Match peak value in the lexer token. Dun, dun. Oh, wait. Maybe it doesn't do that because I have the interface. We have token is equal to token t, right? It is equal to token t. Is this like oh, because I don't export that. Okay. That. Can I say identifier? Not in with. Okay. All right. This pattern match is not exhaustive, so it cannot fill in the missing branches for me, but it at least shows me them, right? I will have identifier. We have end of file. We have punctuation. Have string. Number. Comment. Okay. Well, first of all, if it's a comment, then we just ignore it. Let's do that. Maybe later I will do something with it. We impl node. I cannot just return impl node here, of course. Okay, let's just see what I want to write here. Do I even want to match here? Hold on. I want to try to traverse the thing. Right? Yeah, I need to try to traverse the thing. End of file, obviously, is supposed to... So if we have at the end of file, then I need to terminate at this node. Okay, yeah, ignore will be just impl node, but only after I do Alexer skip. I skip this token and then I go forward. Terminate. What is terminate? Terminate at the node means that I'm going to match node term node. Terminal with some rule on equal yeah, just do that. That's right. Okay, so we have yeah, so if it doesn't correspond to a rule, then you say you fail with would not finish parsing something something. We'll add more details here later. If we have the rule that we correspond to, then I will return the ast. So ast.t is this thing. It's either simpler or complex, right? So I will have a complex one, which corresponds to name, which is a rule name, and then children is going to be the children here. I will need to, yeah, so like since I'm parsing the one, I need to make sure that I'm holding the state. What have I already parsed? let's have a to do here. Okay. Yeah, that's fine. If I have an identifier, punctuation, string, or number, I mean, first of all, I want to see if this is a keyword, right? So we first try to see if this is a keyword here. Token lexer token dot raw peak value. Token is peak value. How about that? At raw token is that. Can I have like the pattern match with a when? Like if I want to have anything like when, and then do another pattern match here, we cannot, right? Yeah, no. So I'm basically what I'm trying to do here, right? I am sending as a specific node in the data structure. I want to try to traverse this this thing, right? There is only two ways to traverse this. We either go through the keyword or we go through the value. Value means that it like parse something, parse recursively, basically. So yeah. If raw token is optional, yeah. So if a raw token into option app, no, there is no if let, of course. Match raw token with some raw token. Okay, if it is some raw token, then what I will do is I'll try to go I'll try to go and use this raw token as a keyword, right? So edge that I'm trying, which will be a rule set edge, is keyword raw token, right? That's what I'm going to try to do here. Okay, let's see, edge type. Let's say this is edge. Then I will say if edge is edge t. Wait, didn't rename it correctly. Hold on. I renamed edge type to edge, and it didn't work. Look at this. Rename edge type. Oh, it doesn't even highlight it. Look at this. Edge type. This one is not even being highlighted. This element cannot be renamed. Okay, the language server is still stupid. Or it's because like maybe it's because the rename only can happen if everything is fully type checked potentially. Let's try. Let's see. That probably is true. Right? I just need to say here that type edge is edge type t, right? And then all of these I want to be like fail with to do. So if everything is type checked, and if then I try to no, look at this. This is still cannot be renamed. I can go to the definition. I cannot rename it. If I look okay at the at these guys, then yeah, maybe it can only rename types and things, but not modules. Maybe modules don't work. Okay, annoying. Edge type is just edge. Okay, so I'm trying to go through the keyword edge, right? So yeah, this is where I try to go through the keyword edge, right? So I say something like this. Node. I have the node. And node next is potentially having this, right? So I need a map. So I need edge map. And edge map. What do I do? Find or something? Find an edge in the map, right? So I want to find this edge in this thing. That doesn't work. The field access has type tool set node. Stupid errors. Okay. So if I have find some next node, then it's something. If it's none, then we don't do much. All right. I have a feeling that I want to do the returnings with exceptions. Actually, maybe. So if there is none, then I don't need to do anything here, right? Yeah. Let's do this with return. I made this function already, actually. With return. Return. Like that. Yeah. Yeah. Um. So yeah, if I basically traverse this edge successfully, right? Then it means that I need to consume the current token. So Lexer skip this token because I have used it to go to the next node. And then I just return the following and pull. I like how everything is red when I write OCaml. I go to the next node basically. Unbound value next. This pattern should not be a constructor. What? Oh wait, find returns the thing. We need to find opt or something, right? Yeah. There you go. Okay, so this is me trying to go to the thing. Let's just see in the comment. How would I write this in a language that doesn't suck? Which could be OCaml, but like if we say something like this, if let some raw token is raw token, then we do the edge. It's keyword raw token, and then if let some next is find opt edge in the node next, then I skip, and then I return the impl next, which technically this is a loop. So I want to like say that basically node is equal next, and say continue, something like that, because this is a loop. And then we have a bunch of parentheses and a bunch of like irrelevant none cases. Which technically I can fix. Let's say this. Try as keyword is a function. Try as keyword is like, you know, optional result. Why are we in VS Code? Well, where should I be? Try as keyword ast t option is, yeah, basically I say this. I say let star raw token is raw token, right? This is basically an if let, and then I say edge is this, and then I say next, which is optional, so we do let star next is this, and then I say lexer skip, and then I say return impl next. Is this better? Is this better? I feel like this is a little bit better. So try as keyword is an optional thing. I don't actually return it here. I actually do that, right? Impl next. And I return some impl next here. No? So this is actually an option, and basically then I say that if as a keyword was successful, right? If a keyword was successful, like so I have this. If try as keyword was some result, then I like return result. Otherwise I do something else. Actually, you know, like we can do it without the return then, right? So basically I want, in case if it is none, then I want to calculate the rest of the thing, basically. Maybe I can do something similar to the let star, but only calculates the next thing if it was none, right? Yeah, so like if we say that let star is option bind, were you making parser in Rust? Yes, I was. But Rust has slow compile time, so we are rewriting it from scratch in OCaml. Can I say something like this? Let plus, or I don't know, like there's not a lot of options here. So I want something like this. I want if I have an A option and I have a function which takes and I have a function that takes unit. Oh wait, but it's not like a let, because like I don't bind it to a value. There's no value there. You know what I want? Like, so I want a function that's something like this. I have an option, and I have a like a value from unit into a, and I can get the a as a result, right? That's what I want. So which means which in Rust is the function which is called unwrap or else. That would make sense. Is there like any other like so we have like the let star or these things, you know, OCaml. Is there like a way to do that too? Are you saying that your parser was slow? No, compiling, not the parser. There's the full language. You didn't only have the parser, right? There is a lot. OCaml. So the let star is a language extension. Which is called binding operators. Examples: you can define the let operator, let star. If none, then none. If some x, then fx. Let's return x. Wait, hold on. Return x is some x. That's just in the end. Table find opt, and then do this. So this is a function that returns an option. Sure. Which is equivalent to this expanded form. Okay, I want like the other one. I want the one that doesn't actually bind any arguments. All right, 1 second. Hello, Nigel. Welcome back. Devin's Dev, hello. Right, just needed to help a little bit there. All right, so I think basically the let binding operators is the only one that is like allowing this custom syntax. So I think unwrap or else can be done. So the way that I can do it here is like this. It's a function. We have option and f. So we match option with none. Right, so this is the opposite of the let star, kind of. Maybe it should be the let divide then. This one was doing something else. It's the one that's just returning none. This is the one that's returning another option. Yeah. So if none, then I return f with unit. Otherwise, if it's sum x, then we just return the x. That's what it's supposed to be here. So basically, the way I will use it, right, is I say let plus unit be tries keyword, right? And this way I don't have the thing. So this is basically a return this if this is sum. Right? Which basically I can say let plus this be equal that. There we go. So like I just try this, and if this returns sum, like if it basically goes to the end, then this actually will happen. I don't know. I don't know. Does this make it more readable? This has a let plus and let star, which is like very weird. And I think other OCaml people are using it for other meanings. I mean, let star is probably the same meaning, yeah. Let plus, I don't know if it is. It does make it less indented though. We don't have like 10 levels of indentation and like useless none cases. For sure. Like this feature is supposed to use for like the monadic operations. More convenient syntax for the monads and applicative functors. But like, yeah. I mean, we could do like a syntax like this, maybe, or like the other syntaxes that is maybe more common. Anyway, so this means try to follow with token as a keyword, right? So I try this. If this failed, which means that we didn't get to the end here, then we go for further, right? Then we go further. This would not be allowed. Maybe it's the more equal or something. I don't remember. Well, there's the double right operator, which is just the binding, right? Do they have this example here? No, they don't. Anyway, this is kind of a little bit more readable, in my opinion, but it requires like understanding this. And like So my problem with this is that it only allows you to have the custom notation like this with the let and some random stupid symbols. Like, I cannot say a completely custom keyword here. Now, mind it would. Yeah, I thought I saw that somewhere. Other libraries were using that. Anyway. So I'm trying to follow with a keyword. And if it's not a keyword, then obviously it is going to be a value, right? So I try. So yeah, we then try. We then try. Let's do this here. Try to follow with a value. So like, because these are the only two transitions that we have, right? Either a keyword or a value. Value means recursive parsing. I will only try to go with a value if there is the edge, right? So edge is a value, right? That's what it is. So the next is going to be edge map find node next. Very similarly like this. We try follow this edge and then this edge. Okay. So this exists now. This is a node. We know that it's possible, that it's there. We will return basically some impl next, right? So we go to the next. What if I call it go? Go next. Go next. All right. And then I say that so inside of this, I need to parse. Right, so the value, the inner value that I actually need to have here, like I need to actually try to parse it, right? And to actually try to parse, which means parse parse impl, I guess. These ones should be like kind of recursive a little bit. So I need to parse. So parse impl will be parse like until parse parse with I don't know. Let's just get it still impl, but like it's taking the rule set, the lexer. It should only take the priority filter, right? Like what is my inner value actually has as a filter, right? Which would be rule priority filter. Right? So we have a rule set, but out of the entire rule set, I only want to parse some which match the filter. Right? So what's my filter? My filter is going to be stored in this node actually. So node has terminal next, and we will also have the what? So like if there is multiple, so previously in the previous implementation, each node had a single priority. But now if I want to allow multiple syntaxes to have the same prefix, and we have and to have different priorities, then what would it be? I feel like I need the maximum and minimum priorities here, or something. Priority range is an optional range. Is there like a range in OCaml? If I say let x be 1 to 5 to 2. That's not working? This is like a special syntax which is only allowed in patterns, right? Range option. Range inclusive option. Let's just have it in the I don't know, I feel like range can even go into this standard X like this. Module range. Something like type inclusive is minimum and maximum, you know? So it's the inclusive range of priorities. Right? Okay. So I say priority range is none. So basically whenever I go through, right, over here I'm adding a rule. Every node that we go through should have the updated priority. Right? So rule is insert this here, right? Insert. I want the with keyword. I hate the fact that I use the with keyword here because I cannot just search for it for all the updates. But yeah, if we finish over here, then I want to say terminal is that. Wait, maybe I should not use with at all. Maybe I should just do that. And then it will tell me some records of undefined, right? So because I will just ensure that I'm not missing anything. Next is a node next. So like this one is not changed, but the priority range is range inclusive unite node priority range, and the one where minimum is equal to priority and the maximum is, I mean, this one is range inclusive point rule priority, something like that. So unite is at function ab. We need a comparison. We need a comparator though, right? We need a comparator, and the comparator is the a into int, right? Is there such a thing? Comparator, CMP. I feel like I want to have a like a module. Like, wait, there's ord, because that's what I derive, right? Didn't I just derive ord? So the order function is a into int, right? I don't know. I feel like it makes it more understandable what's happening here. So a ordering, and then two things, and then the thing. Yeah. Function. So we have the ord function and that, and then we have minimum is ord minimum. Wait, what? Like, is there a function minimum in OCaml? Hold on. OCaml min. There's int min, right? But is there like a generic one? There is no generic minimum function, right? Okay, so we make it over here. The minimum is if you have the ordering. If you have ordering of A, and then you have two A's, then you can get the minimum of those, right? So it's a function ord AB into if ord AB is less than 0, then A, else B, right? That's how you do it. And similarly to that, the maximum is just B, else A. Or we just do ord BA or something. Okay, so minimum is ord minimum, A minimum, and B minimum. And maximum is ord maximum, A maximum, and B maximum. This is less general. The definition has type ord. Wait, B ord. Why can I not see the type of this thing? Oh, ord is like this thing. So which is what? Oh, ord minimum and ord maximum needs like the ordering itself there, right? There you go. That's the problem. Okay. Kind of. I don't know if it's worth it to make like the generic things like that because of how verbose it is in OCaml, but maybe it is useful still. And then I want to have the point function, right? So point is by the hand. I will have the entire Rust tested lib in OCaml. Yeah. I mean the Rust tested lib doesn't have the unite of the inclusive ranges, right? Or does it? A into AT, which is function x into minimum is x and maximum is x. Okay. Node priority range. So this one is yeah, I'm going to match. I want to unite optional, right? Is there a function like this for options? I'm wondering actually. What I want is a function like this. What I want is a function with this signature. With the signature being for all A, if I have an option A option, and if I have a function, if I have a function which takes a and a, so I have an option and I have an a, and I have a function that combines the things together, then I can get the a. Is there like something similar to OCaml in OCaml? OCaml, OCaml? Searching for functions? Would be my process in OCaml. The OCaml equivalent is called odig. Odig is a command line tool to look up documentation of installed OCaml packages. Odig. Okay. Can I install odig? Did you use that, Nigel? Odig. I'm assuming it's in the Nix packages. It is. Let's try it. Odig. OPAM, no such tool found. Oh, this requires OPAM? What if I install OPAM? What is it going to do? Dependency is not a valid type. Oh, because I have this OPAM. Maybe. This one is missing. Is this just in the packages? OCaml says that the ellipse is much smaller. Yeah. Which probably means that this function is not there. Odig. Can I do odig? Help. Look documentation for installed. Command. Cache, changes, doc, log, package, show. Let's see what they were saying. Wait, did I close it? Searching for functions, this one. They say that it's odig. You can install it locally and have it generate documentation for all installed packages. However, generating documentation is not globally searchable. See last point. Besides that, there are a few other strategies. Oh wait, it's not searchable anyway. Never mind. It would definitely be nice to have something like Google with global function name and type signature search. Elm has something like that as well. Merlin has such a feature. Merlin search. Wait, hold on. Merlin. Merlin search in Emacs. What if I have the VS Code with the OCaml LSP? OCaml. I don't know. Okay, never mind. I was just like trying to think what should even my the name of this be. What do you mean syntax error? What do you mean syntax error? There is no syntax error here, don't lie to me. That's general. Okay, so I can do a function or option. Oh, it's like default. It's like map and then or default combined, right? It's basically a map or. Wait, hold on. Wait, what is the std option? I don't know. What would it be? It's like a map or else. Yeah, I guess it is a map or else, indeed. Yeah. Map or else. Indeed. Map or else default. Like, because this can be a different type, right? Because this has B, right? I provide the default. I provide the default, I provide the map function, I provide the option, and I get the result. Like this. Yes. Map or. Wait, I already have the map or. It's the same thing. Holy shit. It's already there. Okay, where did I need it? Where did I need it? Parsimple. Something about the yeah, the nodes, yeah, over here. So priority range is node priority range into option map or this, and then I unite that. Okay. I see. Point. I feel like I need to have the point here, like that. Yeah. I guess the difference is that like the argument, I want it to be used everywhere, so that this let is not necessary. So I have the point. So and then I take priority range and then I map or unite with the point. So either point or unite with the point. Yeah. Either point or unite with the point the priority range. I feel like even without the piping it's better. In this case. Oh wait, map or wait. Oh yeah. We always have some. There you go. We always have some. That. Yes, this is correct. Unite point. Oh, because I need to have the implementation, right? So the implementation here should be float dot compare, right? There we go. Because it's a floating points, or it should be something like rule priority compare. Is there like maybe a module compare? No. Okay. So compare is the implementation of the ord. Okay. Rule type priority is priority t where we have a module priority struct type t is float t compare float compare. Just in case I change this later to a different type. All right, beautiful. Or is it beautiful, or is it? I feel like the priority range is just going to be updated anyway, right? So let's just call this updated priority range, which is going to be used here and in the other place. And I will just say let updated priority range to be equal to that, right? So yeah, over here we say terminal is node terminal, and priority range is updated priority range. There you go. How much lines? Just 160. Still a small program. Value parse impl has type. Rule set. Yeah, so like now I need the parse impl to be called with the with arguments. We have the rule set. We have the priority filter. So the priority filter should be what? Yeah, the priority filter, like, because we have that. And by the way, parse 1 also should have the priority filter, right? Yes, we should have the priority filter here too. Rule. Yeah, we should have the priority filter too. Filter. So I need to like unite the filter. Something. It's not exactly correct here. So filter to do what filter? We have filter, we have lexer. Right, so I parse the inner value and then I go next with this value. Yeah. And by the way, so parse this should return kind of optional. I feel like this should be optional. ASTs after all. Yeah, I feel like so. So I also say let star value here, because parse impl should also return an optional one. Go rule set root. Yeah, so go is the function that returns the ist, which is optional, right? So now we have options. Right? So I return none. Yeah, like this is weird. Like go next. Since I have actually consumed the token, this must result in some in something. Yes, this must result in something. So terminate node turns AST because it must. be there, right? But for example, if I try to parse one, it potentially just returns immediately because I cannot make more progress. Okay. Terminate node. I could just like open my Rust implementation and just copy paste, kind of. Parse one. I also potentially start with a value, right? I potentially start with a value, yeah. Let me just open it just in case. Going to look at it a little bit. Mm, mm, ta-dam. This is the one. Yeah, we potentially start with a value. Yeah. There's also the continuation keywords. Interesting. Parse one. So we potentially also start with a value here. Yeah. Start is an option like this. Um so start it's going to be a named argument. Which means that if I have the start, I need to go the thing immediately. This AST option. Yeah. And also this was actually returning the read one result with either made progress or made no progress. I remember that. Because like I might return some, but it doesn't mean that I actually made progress, right? It doesn't mean that I actually made progress. So this should return parse result. Let's say here type parse result is either made progress, and if I made progress, then then I should have the AST as a result, right? And if I didn't make progress, then it will be no progress, but I still keep the old thing. But I guess since we are in OCaml with garbage collection, I don't need to store it inside. So if I either made progress or I didn't make progress. Yeah, which is kind of similar to an option, but a little different. So yeah, I don't always go from the root. Sometimes I go from the thing, which is like if I already have the start value, then I need to go to the thing. Yeah. Yeah, like what should be the start node here, right? I'm going to basically match the start with some start, then to do. If it's none, then I just go starting with this one. Okay, so go is the one that actually returns not the option, right? It returns the parse result. That makes sense. So terminate returns parse result. So in this case, I say that I did make progress. And I got this thing. Okay. Gotta follow with a token as a keyword. This is done. This, we need to figure out the filter. Yeah, so I just start to parse. Let's call this parse let's call it parse here. But parse should give me, so this one, yeah, I feel like, yeah, this one should give me an option and not a parse result. Right. I think that makes sense. I just need to figure out the filter here, and then I go next. Yes. Good. Okay, and then if I have the end of file, if I have anything else like numbers, strings, whatever, like all of these don't matter. I mean, the punctuation cannot be a thing. The termination cannot be a thing. I mean, end of file or punctuation, I guess, leads to me trying to terminate. I mean, hold on. I'm trying to parse one. This should actually never do anything. This should never do anything. So I guess it's always. I just skip the comments. I just skip the comments, and in any other case, yeah, I just do lexer dot skip comments. And then I just say that I go here. No, I skip comments. And then I just terminate, right? Because I couldn't do anything. Terminate. I think I just terminate here. Let's skip comments. Lexer unit is function lexer while match while token This comment while pick Parser value token is comment. Sure. Do skip. Is that how you do it? OCaml while. Do done. Of course. Of course, there is a do done. I'm actually surprised they don't have like the if end, like the fi. If they have done, then token is comment. Token boolean match token. And score false and true. Okay. So I skip comments, I terminate. Wait, if I skip comments and then I terminate, I don't even need to skip the comments here, right? I always terminate because I only try to follow with a keyword or I try to follow with a value. This is the only things. If I cannot follow, then I terminate. Actually, this makes a lot of sense. Okay. So I either try to follow with a keyword or I try to follow with a value. In any other case, I terminate. Just curious, what you're doing with AI agents? Do they add value to my workflow? No, I don't know. No. I mean, I chat with ChatGPT from time to time. Just to search some information. Even if it could write code for me a little bit faster, that I would still need to check it. I don't think it would speed me up at all. No. I'm an the AI hater. I'm not doing the vibe coding. Okay, yeah. So the thing is, I feel like we should all, so like if I'm doing the parse one, we always have the start, right? So at the very beginning, what should happen? I should always, I should potentially have another start, right? So let start be map dot not map option or not map or just or. What's the function that takes an option? Takes a option bind? No, not bind. Join. What's join? It's an option. Yeah, I guess we need to like figure out. Not the map or, but like or else. Right? That's what I want. or else is the thing that takes a option, returns a option, and also the function, which is like unit into a option, is yeah, so it's function f opt into match opt with if we have some x, then some x, and if none, then f, like this. Okay, so this will be start typed into option or else. Right, so what is this here? So if I don't have the starting value, if I don't have the starting value, then I need to get the starting value. So which is just a reading this simple the simple one, which is just reading a single token and see if I can use that as like thing. Yeah. So this should be a read like parse simple, basically. Yeah, where parse simple is a function that returns AST option. So this is where I actually match the peak value, right? Yeah, parse simple is the one that actually is going to skip the comments here. And I'm going to match the value, and this is where I have it. If it is end of file, then I return none. And then we have a punctuation. So punctuation is never a thing. So we also return none. If we have a number, can I match this? Let's call this token. Let token be that, right? That's what I did before already. Yeah. So we say that the token is this. So match token with that. If it's a number, then I return some simple token. That's what I do. If it's a string, return some simple token. If it is a comment, since I skipped the comments, it should be unreachable. Comments were skipped. Let's have this function in the standard library. Somewhere unreachable is a function that returns never. String into never is basically function s into fail with unreachable reached like that. And then there's the identifier. Since this is a simple one. So for the identifiers, what needs to happen is that not all of the identifiers can be treated as the thing, because some of them are actually keywords and not identifiers. So we need to see if this is a keyword or not. Which yeah. Is this a keyword or not? Yeah. So we say a rule set is keyword. Like, is this a keyword in the current rule set? Then none, else some simple token. All right, like that. And I guess this over here, spend token. So simple token is simple actually spent token. Wait, what? Value to get the spent by expression of type AST simple. Oh, because AST simple has like the token. Yeah. Token, token. I mean, actually, I guess maybe actually it is like that. I will need to attach the span information to the ASTs though later. So what is the is keyword, right? What is keyword? How do we figure out if something is a keyword? So the rule set has the root node, but we also have the keywords, which is this set, the string set, right? Where I say string set is a set make string, right? So this would be keywords is string set emp. Hello? Where's my autocompletion? Empty. When I add the keywords is string set dot add sequence. Is that what I want? I think it's something like add sequence, right? Add sequence needs the sequence, the set, and it gives me the new set, right? So rule set keywords, and to the rule set keywords I add the rule keywords of the rule, right? Rule keywords. This should give me this is basically like the sequence of keywords from the rule. Sure. Let's have that. So the rule as a way to figure out what are the keywords of the rule. So rule into string sequence, right? This would be basically so rule parts. Then we do list to sequence, and then we do sequence map. We do filter. Yeah, we do filter map. Function part into, I mean, just function, I guess. If it is a value, then none, and if it is a keyword, then it is some keyword, right? So that is it. This expression has type string sequence a function rule. There we go. Okay, beautiful. Beautiful. Okay, so we now know all of the keywords in the syntax that we have defined. So whether something is keyword depends because of that. And we need to check in the rule set that something is a keyword, right? So is keyword word in the rule set, right? String a rule set boolean is this function which just says a string set contains has what's the thing? Union to seg, split of list, minimum, maximum, iterate, elements, div, compare, exists. No, exists is like a string into boolean. Equal, disjoint is empty. Wait, how do you like figure out if something contains? What's choose? What's choose? RNG? I guess it's RNG. Compare, div elements empty, filter. Like it's just find. Find gives me the concrete string. Find opt. Why does it return me the string? Weird. Is it like find opt? Is it me finding the word in the rule set keywords and then to see if it is some? OCaml set. Contain. There is no like contains. Alright. It's fine. I guess I could make like an extension for that too if I wanted. Actually, let me do that immediately because why not? How would I even do that? So we have a module set is struct. We include set. Then I say module make t is struct include set make t. This needs a signature, I guess. Oh, it's set.ordered type. There we go. It takes ordered type. The ordered type. Okay, and then I can have something like contains is a in at boolean is function element in the set. I just find opt element in the set. Function is sum, right? It's not general, right? Because we already have the t. Yeah, we have the type element here, right? So it's element into t into bool like this. Yes. Okay. One second. Okay, so contains. Just say string set contains. Like this. Right? This keyword is just that. Good. Good. That's my parser. Okay. What's missing? What is missing? So basically, yeah, I will parse the simple one if needed, or else parse simple. Okay, this is simplified. Okay. All right. So now, if I don't have the start, if I do have the start, then I need to say, if I do have that, then I need to say, if it's some start, then I need to say that well, I mean, there's also like, did I already made progress, right? This was supposed to write one. If I did parse the simple one, like, it also depends if I made progress here or not already. Right? How do I define if I made progress? How do I know if I made progress? So I think we just say this. Made progress is just a function that says that Lexer I mean, the simple part, I think, is just Lexer peak. Dot span dot start, which is the position, you know? If the position is just not equal to the start index, then I made the progress, you know? Where start index is is the start index. Which I don't want to be like that, so I want to say unit into this. Just let start index be that in function that returns that. Okay, where do I have the syntax error? Over here. So basically I say that if I made progress, then I just return the fact that I made progress with this start, right? And if I did not make progress, then I will try to go further with the node. But what is node? But the node is then so the node is a rule set edge map find opt the edge, which is the value edge in the rule set root, right? So node is an optional one. If there is no node like that, then I made no progress. So all of the syntax rules actually start with a keyword, right? There is no rule that starts with a value. That's what it means. All just match with some node, then I go node, and if it's none, then I return no progress. And this needs to be in parentheses. So this over here means that no rules starting with a value. Okay. Unused variable value. Yeah, that's fine because I'm not collecting them yet. Parse rule set into this. So yeah, basically this is parse one, right? So what I'm going to do here, in order to parse the full thing, we have the priority filter, and we have the rule set, and we have lexer, right? Rule set filter lexer. So what we are going to do here is I'm going to say let AST is parse1 in the rule set using filter and lexer, right? All of these. Or I guess result, right? Or I guess I'm going to match with. So if I made progress and I got the AST, then I do something. And if I made no progress, then I'm going to stop. This is going to basically be a loop. So what happens here? We are making the parsing algorithm where we parse the minimal possible expression, and then we are going to try and expand it in a loop, basically. You know, so we start with the with this thing that we have started with, you know. So yeah, I have let recursive loop is a function. Like, what's my currently parsed thing, right? So like already parsed, right? What did I already parse? I already parsed an optional AST because I maybe didn't parse anything yet, right? And then we just call the loop with already parsed, and initially it's none, obviously, right? So we start with already parsed and everything. So now, so if I made progress and I have the AST, right? Then I might want to try to make even more progress, right? So how do I try to make even more progress? I just call the loop again with already parsed being some AST, right? So I just go into the loop. And if I made no progress, this means that no progress can be made, and I just need to return this thing, which is basically the thing that I have already parsed, right? So what I have already parsed is what we have. That's the entire thing. That's all, right? So we try to make progress, and when we no longer can make progress, we stop. We stop, right? And that's simple. Okay, and then the external function. Right? Yeah, like this is going to be, you know, module impl, because I want this to be like private, kind of. Right? And then we have the actual function parse, which has the source and the rule set, and gives me. So like this is still optional, kind of AST, right? Yeah, let's see. Like it's either that or I should make it have the empty AST, which I feel like I don't know. I feel like maybe shouldn't be there. Yeah, let's keep it like that. Actually, so this is function, source, and rule set. Where I just say implementation parse. This needs the lexer, so I initialize the lexer. And then I parse with the rule set. Rule priority filter is any, right? Because when I just parse the source, I start with no filter, and then I give it the lexer, and that's it. That's my public API. Okay, so in the test parser, I just say parser.parse source with the rule set. And then we fail with to do test. Okay, sure. Sure. Tune test. Jobs 1. Okay, we have an infinite loop. Beautiful. I love infinite loops. I love infinite loops. Parse. Made progress. Wait, do I even return the no progress? I never return no progress, do I? Yeah. I never return no progress. Or do I? Oh, no, wait, hold on. If made progress, then made progress. Yeah, return no progress here. Because there's no rules starting with a value. But also I should make no progress. Yeah, over here, terminate is not necessarily made progress, right? It depends. It depends here. Because this... Yeah, I guess we say if made progress, then we made progress. Otherwise, no progress. This doesn't work. Okay. Okay, I want to know where. So we want to do print line hello. Wait, I'm not even getting here. Wait, what? Then where's my hellos? Test. Wait, hold on. Am I even not getting here? Fail with yo. I guess not. No, hold on. I did fail here. All right. I was thinking that maybe the rule set couldn't be really created. Yo. Yo. Wait, does printing not work in tests? How do I make it so that I can see the yo? Dune exec test parser. Test parser? Wait. Test parser doesn't match any known tests? What is this then? What is this then? Maybe I'm writing my tests incorrectly? I don't know. Hmm? Yeah. /n. Like, is it not like, is it capturing the output or something when I'm doing the tests? How do I print during tests? What? Dune run test and print. Dune run test. Wait, there is Dune run test? Dune run test. Run test. Test parser. Do I need to say parser? Running tests. Run a single test. Use Dune exec to run the test executable. Projects test my test ML. Why do you have the exec here? Run cram tests. Oh, it's cram tests? What's cram tests? Cram tests are expectation tests. A shame shell-like syntax. I see. It's something different. Dune exec source parser test parser z ml parser test parser exe. That works. Yes, that works. So we must say exe here, which is very weird, I think. Okay, fine. Okay, so if I say here eprintln yo yo yo, then why do I not see it? Why do I not see it? That makes no sense. Let's say prayer. New line. And line. Yo yo yo. Okay, actually this one works. Wait, eprintln doesn't work? Because it's the error formatter? Oh, maybe like the prayer actually flushes or something? Right? Maybe it doesn't flush. Here, and that's the difference. Can I flush the thing? Is there a thing such as format flush? Print flush? So print flush, for example. Is pp print cut. It's the deformatter key. Flush. So this should not be /n, right? I have flush. Out channel. Unit. Camel ML flush. What? Flush all. If I have the format flush. I guess pp print flush is what I want, right? Pp print flush, and there is no documentation for it, of course. So just do pp flush mt. Wait. Hold on. Format dot flush. Oh, pp print flush. Print flush. fmt. Expression as type. Print flash. Oh, there is a unit here. That must happen. Okay. Yo yo yo. Okay, so that works now. Parse. Print started parsing. So I started parsing. Parse. Trying parse 1. Trying to parse 1 to make progress. Whatever. So yeah, we try to make progress forever. And why do I do that? I probably just don't. I actually, yeah, that actually makes sense. It actually makes sense here. It actually makes sense. Let's say this, let result be that, let star result be that. I will return some result. We'll also say that elixir skip, because I didn't consume the token here, basically. And then now you have unbound because of the inference being stupid. Okay, can I say AST T? That doesn't work. How do I make the type inference to work? Like, well, like, why is it being inferred based on a name and not based on the type, which is known here? I know that this must be the AST, so like, you should be able to figure this out. You know? Like, what? I need to do the whole mesh statement and annotate that as ASTT option. Does that work? I cannot even annotate. This cannot be annotated even. Wait, why can it not, could that not be annotated? STT. I can do that. Yeah, see, like, if I have this type annotation here, then this works. Otherwise it doesn't. This is so stupid. This is the stupidest part of OCaml. Maybe, I don't know. Why is type constructor in OCaml not being inferred by the type? Wait, can I say over here then ast.simple? Okay, if I say ast.simple, then it will figure it out. All right. I guess that makes sense. Okay, fine. That's better than annotation, I suppose. Okay. All right. Now I want to say that I made progress. Okay, so if this function is being called here, if I made progress, if I made progress, I want to say something here. I want to print ln made progress into %a, which is ast print ast, right? I want something like that. So ast, I want printing here. Print for matter into ast into unit. If it's a simple token, then I just token print token. And if it's a complex with name and children, then I just say f print f fmt %s name. Let's just have the name for now without the children. Well, actually, yeah, like I will only have this thing. Token print. Yeah, so AST should depend on the lexer. Yeah. So like this is lexer token. The value token was type simple. Yeah, simple. So I made progress some string, right? Wait, interesting. Some string. We are doing the test, which is this some string, right? So I did this, and then I did that. Okay. And then what happened? And by the way, where did the opening parentheses go? Shouldn't I have parsed those? Parse. Made progress. So this is just like the simple ones. So I parse one. Made progress some. Oh, I see. I think yeah. It's understandable. It's understandable. Let's go here. This should be this over here. This means that I have followed with a keyword, right? So I say, since I have followed successfully, I should just print ln followed with keyword this, which is the raw token. And then over here, I should say println followed with value a st print value, right? Like that. Yeah, so like we made progress some, and then I tried to follow that with a keyword, and then I made progress some, and I followed with the keyword this. I made progress string, and then I should have made progress. Oh wait, hold on. It says followed with keyword opening bracket. Like yeah, okay. So it didn't say followed with a value, right? Yeah. No progress is already parsed. Yes. So this should be basically start. This is my result, right? And then I return the result just so that I can log it, you know? I print start parse one. Started to parse one. Let's like match start here with If it's none, then we just started to parse one. And if it's some start, then start to parse one. Having you. I guess I don't really care what it is here. And then over here, before returning the result, I will say finished parse one. Match result. If I made progress, then finish parsed one made progress. No progress. So I always start to parse one. Hold on a second. Can I like output to out? Okay, so I started parse one. I finished one with because I made progress. I read a simple token, which is sum. And I started parse one, and now I have the value sum. Oh wait, hold on. I started parse one having value, and then I start to parse one again. Wait, what? This makes no sense. Oh wait, or do I? Or does this make sense? Yeah, it does make sense because I have the function application. So I'm continuing. This starts to parse it as the function application. So I continue the function application starting with an opening bracket. Right? So I start parse one. I made progress. I see that there's another sum. I open bracket again. I start to parse one inside like the inner bracket, and then I made the progress having the string, and then I have the value here, and this should stop basically. This should return none. So like, why is this happening? Start to parse one and start to parse one. So like, I don't have the value, right? Is the important part here. So I don't have the value. I don't have the value. I mean, yeah. Oh, hold on. Actually, I do have the value, right? Oh wait, I don't have the value. Oh, I don't have the value? I do not have the value, and I go from the root. I go from the root. I see that I cannot... Oh, and then, yeah, and then I try to follow the value. Yeah, that's right. Yeah, I should never try to follow with the value if I made no progress so far. If I made the... If I didn't make any progress so far, then I shouldn't even try to continue to follow with anything. Yes, that makes sense. But let plus if this returns none. Star is match made progress with true. So if I made progress, I make sum, and if I didn't make progress, then I don't want to. Right? This is like the early return for me. Actually, don't. If we are just starting. Or what? What is the condition here? Like, there is some condition here. Let me just take a look at my old code. Down, down, Da-da-dum. Should resume. Oh, not sure actually here. Oh, yeah. This might like be better. So this actually finished, right? This actually finished. Start parse one having value. Could not finish parsing. Yeah. So now I come over here. Could not finish parsing because that's what I'm trying to terminate, but the node is not terminal. Yeah. Parse result. Yeah. Well, I mean, if I cannot terminate, it might be because I am in the root, right? It might be because I am in the root. So if I am in the root, so... Or rather, if I made no progress. So if I made progress, then like I should do something. Otherwise, I should just return no progress. Think this. Okay, and then we have the to-do test. Okay, does this mean that I actually finished it? Okay, so we have this source, which has been parsed. Let me try println parsed ist print ist, right? Well, I mean HAST with if it was some AST, we'll do that. If none, fail with thing was parsed. Fail with to do. Okay. So I parsed some. Okay. Which actually makes sense, but I need to show the children. Let's improve the printing here. Let's improve the printing. So I have the children, which is the tuple. And then I should say this percent %a and tuple print children. But tuple print needs the child to be printed, which is print, which means that it's a recursive one. Okay. Like that. So tuple print is formatter into at into unit, given that I know how to print the thing, which is formatter into a into unit, right? One print value fmt tuple. Okay, so what I do here is it's going to be similar to the list print, kind of, right? So it's going to be format stdx print from the list. It's very similar. Let's do curly braces, and then we do pp print iterator where the separator is going to be comma, sure, and then we print the value. But then what's the list, right? Yeah. Well, first of all, we go over people unnamed, right? Named and named is what we have. So we pretty print the unnamed ones. Is a list. If we print iter, we have the iterations. List iter. That has type A array. Oh, it's array. So I need to do array iter, right? Right. So this is printing the unnamed ones, and then I want to print the name ones too. Maybe like a trailing comma here. Format comma separator empty, but only if table empty, table length of named is not 0. Then we do the comma separator, and then I print the using hash table iterations. We do the named ones. Hash table dot iteration. Yeah. But now I don't print the value, right? Now I don't print the value because now I have print named. So print named name value is going to be and this also requires the FMT, right? So this means printf FMT percent %s is equal to %a, where we show the name and the print value, right? Unused variable print named. What? It literally is used here. What? What do you mean unused variable? Is this a different one? Hash table iterator has the type AB unit hash table, but expected was a unit. Oh, this is annoying. Because this creates me like, yeah, I need like iterate paired or something. That's weird, I guess. So iterate with a function, right? Yeah, I have function f, and then I basically iterate with another function which takes name and value and calls function with name and value. Is that it? And then print name should actually have the name and value, like, because this print is supposed to have these single arguments. This is actually weird a little bit. Maybe there is a better way of doing it. I don't know. To do test. So we parsed some. This didn't work. Wait, hold on. It didn't even print this. People print is being used over here. Down F, print F, MT, simple Token print token. I parsed the simple sum. Yeah. Wait, hold on. That's weird. Also. Start to parse 1. Finished this. Made progress simple. Start to parse 1 having value. Yeah, now I cannot make any progress because I'm not actually starting the thing. Yeah, that makes sense. That makes sense. It specifically is about the yeah, so like I need to try and go into here. This is not correct. Actually, don't, we're just starting. But if I'm just starting means that if the start was none, I feel like match progress, I need to have made progress. Or start should be is some. You know, maybe that. So now I might progress simple sum, followed with keyword opening bracket, simple sum, opening bracket, simple string. No progress, we're finished. So now I followed with this simple string. And then it says cannot finish parsing. Cannot finish parsing. Peak is token print laxer peak value, right? It says peak is wait, hold on. Peak is double closing bracket. What? Peak is a double closing bracket. Wait, what? Is my laxer incorrect? Or is my test not correct? Oh, it is incorrect. Yeah, that's right. That's right. Let's try space here. Because I actually parsed this as a single token. That's the laxer that needed a little bit more work there. Okay, so I followed with a keyword this, and I have a to-do. To-do is over here. Yeah, the children. And to actually collect the children. This is why this value is was being followed with a value. This one is not used, right? Yeah, so I need to know what are my values here. So when I'm parsing one, I'm going to say that let parsed values is going to be a ref to an empty list. So this is a list of ASTs. Right? It's going to be a mutable one. So every time I parse a value, since I've followed with the value here, since I followed with the value here, I will say that, well, I mean, this should be like option to list start, because that's my starting value, kind of. Right? And then whenever I follow on the value edge, and to say that parsed values is list append, no, is value and parsed values, right? So like I added to the head, actually. Yes, added to the head. Right. So then over here, I say children is collect, like rule, collect parsed values using the rule. So rule collect like given basically the list of ASTs and the rule, I construct the new AST, which is this complex AST corresponding to this rule. So it's going to be a function, values, rule, right? So it's going to be a complex it's going to be AST complex with a name being a rule name, and children be be collect values using rule parts. These values are in reverse though. Like I feel like, yeah, or I need to append to the list on the other side. Maybe I should just append to the list on the other side. For now, it's fine. Name is rule name. So we're collect. So collect recursive. We have AST list, and we have the list of, and we have the list of rule.
Hello, Dev 9-inch nails ya.
Hello, hello. I'm doing OCaml again. Yeah, I started yesterday. AST list and the part list, and this should give me the tuple of ASTs. Okay, yeah, there we go. So this is going to be function values parts. So I'm going to match values and parts as a tuple here. It's either, so basically if the part is if the part is keyword, then I don't really care about this. I'm only collecting the values here, right? So I keep collecting the values, keyword, and then the parts tail, kind of. I just keep the parts tail here. If I have a value, and then rest values tail And then I have the value. Binding into parts tail. Then I need to collect values tail, parts tail. Syntax is incorrect. It's impossible to see anything in OCaml with all the red lines. Pattern matching is non-exhaustive. Yes, but what's the syntax issue? Isn't there a syntax issue? Where is it? Oh, it's in line 60 actually. What? That makes no sense. That makes absolutely no sense. Line 38. Oh, character is 60. Yeah, line 38. Because in the vertical bar. Okay. If I have this over here, so I should basically I connect value and binding, and then I add this over there. Yeah. So values and say tuple dot add to those the binding name and value. So tuple should have a method called add, which is basically has a string option, which is like the name of the field, the value of the field, the current tuple, and it extends it with a new value. So function field, I don't know, name value tuple into match name with some name. Then I say tuple with named being hash table add tuple named. You know what? I'm not going to use the hash table here actually. I feel like hash table is like having the inverse arguments and shit. Maybe later. Tuple named name value. And if I have none, then I have tuple with unnamed being array append array push. How do I add one element to an array here? Okay, I can make an append. Concatenation of v1 and v2. Tuple named and array make one value, I guess. Ugly. Oh, hash table add is actually mutating. Yeah. You know what? This shouldn't be a hash table because this one is mutable. Instead, say string map. String map contains one. Yeah. So it's just like a string map t, right? String map add like that. If it has type string option. String map, which is less general. Hold on a second. What's cardinal? Return the number of bindings of a map. Instead of length, we use cardinal. Why don't you just call it size? Okay. Cardinal. The weird choice of words here. String map iter actually works. Okay, this is the only one that doesn't. The definition has type string option into string map t. What? No. Hold on. Value name is string option. Value is a. Tuple is at. And this returns at. What are you saying? These stupid errors are so bad. Less general than for a string option. But like, where is this string map t? Tuple with named being string map add tuple named. So the reason for trying OCaml again, trying to have the faster iteration cycle, slow because the Rust is too slow to compile, and also just for fun. It's fun, right? Right? Like looking at this error message. I gave this definition the type, and it's like the error is actually somewhere else. This error is false. This is literally the type. Like technically it should be like this function type A, I guess. Kind of, right? Okay, there we go. This is my actual error. This is my actual error. Like the reason that these error messages like are wrong, I don't know how the like the expression of a string map t has an expression was expected of a string map t. Yeah, so this is my actual error because add has yeah, I need to like add name, value, and then string tuple name. There you go. This is the actual thing. Like, why did I need to do that to see the actual error? Is my opinion about Zig still as the same as half a year ago? Why would it change? How would my opinion change? I can do more Zig. Zig is similar to OCaml in some ways. Of its too much of explicitness, for example, the way I'm doing the modules instead of having type classes. So I don't know if I can. Yeah, I don't know. Like, I don't want to think about the low-level details though at all. Kind of. I don't know, maybe like what would be the good project to try Zig again? It's definitely not making a programming language though. Making a programming language, Zig is the wrong tool for that. I mean, Zig is the wrong tool for everything, I think, but like what's not so wrong to do in Zig? Why? Because like the only alternative, Zig is supposed to be the alternative to C. I don't see the reason to use C, so I don't see the reason to use Zig. What's the reason? Like, what do you use it for? Like, if it brings you, if it's for fun, I guess for fun is a valid reason. If you like having fun, then you should maybe write Zig. But I don't think it's a very productive language. I didn't write much of it, so maybe I mean you can be productive in anything, I guess, even if you write brainfuck with enough practice. It looks shiny. It looks like there's a lot of missing features in the language, so like why would I use it? OCaml better than Go since both are garbage collected. Garbage collection doesn't matter, in my opinion. I mean, it matters, but like that's not what matters most of the time. Okay, I guess that's the use case of Zig. It's like if you hate garbage collection, if you write for embedded software, but even then Rust is better. But if you have skill issue with Rust, then you go for Zig. Yes. Or if you don't want the slow compile times, which is valid, of course, but like, yeah, I just don't see how Zig is usable on big projects. Is there any game written in Zig which is like big game? I mean, not there is no big games in Rust either, right? So that's not really a good point. I don't know. I'm just a hater. Okay, collect. This has a non-exhaustive pattern matching. Yeah, so basically if I have an empty list on the left side, but I have more here, then this should Amana. If I do this, then I should fail with not enough values supplied. And if I say the empty one is on the other side, then I should fail with too many values supplied. All right, there we go. So rule collect is the one that actually returns this complex stuff. So I just do that. We made progress by collecting the rule and the parsed values, like that. Followed with keyword. Not enough values supplied. What? Yeah, followed with this, and then not enough values supplied. What are my values though? Let's see here. Println collecting and d values list length values. Collecting one values. Yeah, it is one values, right? And what's the rules? Into %s, and the rule should be rule name. Like it's supposed to be the scope, right? I suppose I was collecting one values into scope. This is supposed to work. What's the problem here? Because the scope has a single value inside, right? And I am trying to match a single value. So this should work. What's the problem? Oh, yeah, if they are both empty. I'm stupid. If they are both empty, then we should return tuple empty. There is no empty tuples. Empty is unnamed is array empty. Named is string map dot empty. Array empty is not there. Array make and not make is an empty array, really. Init. Init 0 function unreachable. No? Oh wait, there is a syntax for it. We just do that. Right? There is no constructor because there's syntax. Okay, so I parsed apply, where argument is sum and function is another apply, where argument is sum and function is scoped simple string. Okay, this is actually correct syntax, correctly parsed stuff. This is actually correctly parsed stuff for this test. There is more missing parts. There is some stuff in the lecture that I need to fix. But other than that, let's see if the other one works. Kind of. So I did parse. I parsed if where condition is simple B, where else is apply F to X. Okay, this is incorrect because, yeah, they are in reverse order, right? That's the last thing that I'm going to do. Collect. Collect. When I'm calling it, I want to have a list reverse parsed values. Okay, yeah, there we go. So I'm having if condition apply F to X, then A else B, right? And this is exactly what I have here. So this was correctly parsed now. Okay, there might be more bugs, but I need to end this stream for today. It's basically there though. Like the entire thing is there. I'll fix a couple bugs. Maybe I wasn't explaining the algorithm well enough, like always, but yeah, I feel like trying to explain and struggle with OCaml is difficult. All right, there we go. Some actual language. The OCaml, async, Rust, nice. Begin, let, if, want. Making a Lisp, right?
Because the other one from earlier got clipped off by the break.
Okay, see you guys next time. Bye.